This is Mr. Coin for Coin Maths. This is your Mega National 5 Maths Exam revision for 2023. This will cover the whole of numeracy, algebra, geometry, trigonometry, statistics, every single thing. If you prefer to take your time, go through each individual video that I've already done. This is your last minute. I'll try and be as comprehensive as possible. Let's get straight into it. 2022, just last year, paper 1, question 1, evaluate 2/5 times 1/5 plus 3/4. So again, bid mass brackets first. 1/5 plus 3/4. Common denominator is 20. 1 times 4 is 4, plus 3 times 5 is 15. 19 out of 20. So we've still got this 2/3 to times by. So step 2, 2/3 times 19 over 20. 2 times 19 is 38. 3 times 20 is 60. And they are both even, so I can divide by 2 to simplify. A half of 38 is 19, and a half of 60 is 30. 19 is a prime number, it doesn't go into 30, so that's me simplified for my final mark. 17, paper 1, question 3 says, evaluate 1 5/6 divided by 3/4 and give your answer in its simplest form. So we change the mixed numbers into fractions first. So 1 5/6, 1 times 6 is 6, plus 5 is 11. So that becomes 11 over 6 divided by 3/4. So that becomes 11 over 6. Dividing by a fraction is the same as timesing by its reciprocal. So flip the second one upside down, 4/3. We can now simplify in advance or at the end. So I can divide this one by 2 to get 2, this one by 2 to get 3, and then our final answer becomes 11 times 2 is 22, 3 times 3 is 9. Just double check there's no more simplification. There is not. At this stage I can leave my answer like that. I do not have to change it back to a mixed number, so that's fine. If I did change it back to a mixed number, I would get 2 and 4/9.
10. Tommy buys flower seeds from a website. He's given a 30% discount. He pays £16.10. Calculate the cost without the discount. No time in this question, so I'm probably dividing. So 30% discount, which means 100% minus 30%. That means he's paid 70%. So we know that 70% represents £16.10. We could go down to 10% and back up to 100% hopefully. So let's just go down to 10%, divide by 7 to give me 10%, divide by 7. So that gives me 7 2s are 14, 2 left over, 7 3s are 21, and 0, £2.30 for 10%. So 100% must be £23.
SQA National 5 Maths 2019 paper 2 question 9. Georgia had a roof repaired. She's charged an extra 2.5% for late payment. She had to pay a total of $977.85. How much would she have saved if she had paid on time? So we need to realise that 102.5%, 100 plus 2.5% equals $977.85. So we need to, usually we go down to 1% and back up to 100 because usually we want to know how much it cost before, but this time we need to read the question. How much would she have saved? We just need to work out what 2.5% represents. So to work out 1%, we get our calculator out and do 977.85 divided by 102.5, and that gives us an answer of £9.54. And therefore 2.5% is what she paid, so I do 9.54 times my 2.5, and that gives me a final answer of £23.85. So she would have saved £23.85.
Company's annual profits is increasing to 215,000, increased by 3% a year. What's the per annual profit by the end of 2025? So our multiplier, 100 plus 3 divided by 100 is 103 divided by 100, which is 1.03. Start with 100% added 3%. So we take our money times by our multiplier to the power of 4, because it's 4 years between 2021 and 2025. And that's called appreciation. If you do that in a calculator, you get something like 241,984.39, which to the nearest £1,000 is £242,000. And we're done. Couple of past paper questions standard form. So 2016 paper 2 question 2. A pollen sample weighs 12 grams and contains 1.5 times 10 to the 9 pollen grains. Calculate the weight of one pollen grain in grams. Give your answer in scientific notation. So it's asking me for the weight of one of the things. So I need to divide by 1.5 times 10 to the 9 to find one of them. So the sum I'm going to do is 12 divided by 1.5 times 10 to the 9. And I'll put that in brackets to remind myself that when I get my calculator out, I'll need to use a brackets around it. So that's 12 divided by 1.5 to the power times 10 to the power of 9. That gives me 0.0000000008. So I just write that down. 0.00000008. I have to give my answer in scientific notation or standard form. So I just do that in the same way. 8 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9 minus 9. There are 3 times 10 to the 5 platelets per millilitres of blood. On average, a person has 5.5 litres of blood. On average, how many platelets does a person have? Give your answer in scientific notation. So I have to work out how many a person's got in total. I need to times. So I need to do 3 times 10 to the 5 times 5.5 litres, but I need to times that by 1,000 because there's 1,000 millilitres in a litre. 165, 1, 2, 3, 4, 5, 6, 7 zeros. So that equals 1.65 times 10 to the power of 9. 7 zeros plus 6 and 5 make 9.
2 planets in our solar system. The volume of Venus is 9.3 times 10 to the 11 cubic kilometres. This is 85% of the volume of Earth. Calculate the volume of Earth. Notice it does not say it's went down by 85%. It's just telling you that it's 85% of the volume of Earth. So 85% is our multiplier. Okay. So 85%, change that to a decimal. 85 divided by 100, 0.85. So we now just take our number, 9.3 times 10 to the 11, divided by 0.85 to get back up to 100%. 9.3 times 10 to the power of 11, divided by 0.85, and we get a huge number. So we've got 109,411,76,470,58.82 cubic kilometres. Now, doesn't ask us to round it or anything like that, but it's not a very reasonable number. So I will, just for the sake of this, round this to the same degree of accuracy as the question, so 2 significant figures. So that gives me 1.1 times 10 to the power of, well, all the numbers after the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to the decimal place, to the power of 12, and it's cubic kilometres, so kilometres cubed.
2015 paper 2 question 6 on volume. We've got 2 parts to this. Part A says the Earth is approximately spherical with a radius of 6,400 kilometres. Calculate the volume of the Earth, giving your answer in scientific notation, correct to 2 significant figures. And then part B says the approximate volume of the Moon is 2.2 times 10 to the 10 cubic kilometres. Calculate how many times the Earth's volume is greater than the Moon. Okay, so let's start off with part A, which is a straight volume question. Once we've done part A, we're going to do part B, which is a scientific notation question. 6A, since we're using a sphere, it's 4/3 pi r cubed. Get that from the start of the exam paper. So that's 4/3 times pi times the radius 6,400 cubed. That equals 1.098 times 10 to the 12, which we round that to two significant figures, so that's 1.1 times 10 to the 12 kilometres cubed for our final mark. Part B, the approximate volume of the moon is 2.2 times 10 to the cubic kilometres. How many times the Earth's volume is greater than the moon's? How many times? So I need to do the Earth's volume divided by the moon's volume. So step one, identifying that we need to divide. So we do 1.1, the big number, times 10 to the 12, divided by, or the divide sign, 2.2 times 10 to the 10. Get a mark for that. And then once we divide, just make sure we put that in the calculator with brackets, divided by brackets, you get 50. And we're done there. Expand and simplify. So we've got root 10 times root 10. Well, that's just 10. We've got root 10 times root 2. Well, that's going to be root 20. 2 tens are 20. And we've still got plus 8 root 5. So at this point, we need to check if root 20 can be simplified as a surd. We're looking for two numbers that go into 20. One's a square number. Hopefully it'll be 5. Let's just check. Root 20 equals root. Well, 4 is a square number times 5. So that gives me 2 for square root and 4, root 5. So I can rewrite my problem as 10 minus 2 root 5 plus 8 root 5, which equals 10. 8 minus 2 is 6, so plus 6 root 5. And we're done. Can't add the 10 and the 6 root 5 because they're, well, different from each other. One's a whole number, one's got a root in it.
SQA National 5 Maths 2019 Paper 1 Question 12. Express root 2 over root 40 as a fraction with a rational denominator and give it in its simplest form. So we've got root 2 over root 40. You can simplify now or after. So we'll simplify after. Root 40 over root 40. That gives me 2 times 40 is 80. So root 80 on the top. And root 40 times root 40 is just 40. So simplifying our root 80, we're looking for two numbers at times to make 80. One's a square number, the biggest you can find. 16 goes into it 5 times. So that is 4 root 5. So our final answer is 4 root 5 over 40. 4 goes into 40 10 times. So that's root 5 over 10. And we're done there.
Question 11. Simplify m to the minus 2 to the power 4 times m to the minus 5. Give your answer with a positive power. Watch out. Final bit. So you've got m to the minus 2 times 4. That's m to the minus 8 times m to the minus 5. So add the powers. Minus 8 plus minus 5 is minus 13. And I'm almost done. That's 1 over m to the 13 using the fractional rule for negative indices.
Laws of indices. SQA National 5 Maths 2017 Paper 2 Question 12. Express 1 over the cube root of x in the form x to the power of n. So we've got 1 over the cube root of x. You need to know from your laws of indices that a cube root can be written as x to the power of a fraction. The fraction is 1 over 3, 3 from the cube root, and because x has got like an imaginary 1 here. Once we've done that, your second law is if you've got a fraction, you can make the fraction disappear, take that up to the top, and that becomes a negative power. So in other words, we get x to the minus 1/3 for our final answer. Okay, laws of indices. SQA National 5 Maths 2015 Paper 1 Question 14. Evaluate 8 to the power of 5/3. Now it's a non-calculator question, so we're going to have to change it into a format we can work on. So 8 to the power of 5/3 from the laws of indices. That is a root. And what type of root is it? Well, the bottom number tells us cube root. And the 8 and the 5 go along underneath the root. So it's the cube root of 8 to the power of 5. So I can either cube root first or after the fact. Might as well do it first because 8 to the power of 5 is a hard sum. So the cube root of 8 is 2 times 2 times 2 is 8. So that gives me 2 to the power of 5 still. It's just the cube root of 8 I've done. 2 to the power of 5. That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and we're done there.
Expand and simplify. I'll do this in my usual way by drawing a box. On one side goes one bracket, 3x take away 2, and the other side we've got 2x squared plus 5x take away 1. Also, there's lots of ways to do this. I'm just trying to get all the ones correct. So 3 2s are 6, so I've got 6x cubed. 3 5s is 15, so I've got 15x squared. 3 1s is 3, so minus 3x. 2 2s is 4, so minus 4x squared. 2 5s is 10, so minus 10x. 2 1s is 2, so plus 2, because minus times a minus is a plus. So that gives us 6x cubed. We've got 15x squared minus 4x squared, so 11x squared. We've got minus 3x minus 10x, so minus 13x. And last but not least, plus 2. Okay, next question.
SQA National 5 Maths 2018, Paper 1, Question 2. Expand and simplify. Well, I always use the box method for this, so I'm not going to stop now. So I've got one set of brackets on one side, 3x plus 1 times x minus 1. So I'm going to expand and simplify that. And then it's plus another box, 2 on one side times x squared minus 5 on the other. So I can now easily expand it using a different colour to highlight the answers. 3x times x is 3x squared. 3x times minus 1 is minus 3x. 1 times x is plus 1x. 1 times minus 1 is minus 1. So there's my first set of answers. And then over in the other box, 2 times x squared is 2x squared. You might want to put a plus. And 2 times minus 5 is minus 10. And then taking our answer outside the box in. Collecting like terms, so looking at our x squared, so we get 3x squared and 2x squared, so that's 5x squared. Looking at our x terms, being careful, we've got minus 3x plus 1x is minus 2x, nothing in this side, so it's minus 2x. And looking at our number parts, we've got minus 1, minus 10, so that gives me minus 11, and I'm done there. Fractions and factorising. So routine factorising, SQA National 5 Maths 2017, Paper 2, Question 9. Part A, factorise 4x squared minus 25. So when I'm going to factorise something, I see if there's a common factor. Common factor for 25, there's no common factor, so it's definitely double brackets. So I can do my double brackets straight away. And this is called a difference of two squares because it has got a minus, it's got two things, it's got an x squared, and then it's got just a number. So I square root the first term, 2x and 2x, and a square root the last term, 5 and 5. And then it's just plus for one of the brackets and minus for the other. And we're done there. Part B, hence simplify 4x squared minus 25 over this other quadratic. So we've already factorised the top, so let's factorise 2x squared minus x minus 10. There's a number of ways you can do this. But one of the simplest ways is to times the 2 and 10 together. So I'm looking at 2 times 10 equals 20. And I'm looking for numbers that times together to make 20, but add together to make minus 1, which is the middle term. Now really it's minus 20, but I'll just do 20 and then I'll fix it later. So I've got 1 and 20 I could pick. 2 times 10 is 20. 4 times 5 is 20. And that's them all. So 1 and 20, I can never add or take away to make minus 1, so it's not that one. 2 and 10, I still can't do, so it's 4 and 5. And how do I make minus 1 from 4 and 5? Well, it must be plus 4, take away 5, and then just double check. 4 times minus 5 is minus 20, which is what I want, minus 20. So now I can take my 2x squared minus x minus 10 and rewrite it as 2x squared plus 4x minus 5x, just splitting that middle term, minus 10. And then you can imagine a imaginary line down here, you're going to factorise each side. So factorising the first side, 2 is a common factor, but so is x. So I get x, 2x times x is 2x squared plus 2, 2x times 2 is 4x. And then the other side has to have the same bracket again, so I'm just going to write x plus 2 and work backwards. So I've got 5, so I need 5 times x, but it's minus, so it's probably going to be minus 5, and just double check, minus 5 times 2 is minus 10. So that means in fully factorised form, I can double bracket it to get x plus 2 for one of my brackets, because that appears twice, and then what's outside the bracket? 2x minus 5. So I can write 2x minus 5. So going back to our question, now that I factorised that, we had 4x squared minus 25 over the quadratic. So let's just write that again. 4x squared minus 25 over 2x squared minus x minus 10. Well, that's going to equal, factorise the top already, was 2x minus 5 and 2x plus 5. And the bottom we've just factorised to get, I'm going to write the 2x minus 5 first, so it's really clear, and x plus 2. Doesn't matter the order we write your brackets. Now, you should be able to see that you've got the same bracket top and bottom, so they cancel each other out. These don't cancel because they're not the same. So our final answer is simply 2x plus 5 on the top and x plus 2 on the bottom, and we're done there. Solving quadratic equations by factorising. SQA National Maths 2018, paper 1, question 5. Solve x squared minus 11x plus 24 equals 0. So you should recognise that's a quadratic or trinomial because it's got an x squared, an x and a number. So since it's paper 1, I know we're factorising most of the time, because if we use the quadratic form, we're going to get decimals. So unless it tells us to in paper 1, factorises. Looking for a common factor, there's no common factor, so straight away it is double brackets. And this is quite a simple one. If it's just an x squared, I can write x and x straight away. To get my other numbers, I'm looking for two numbers at times to make 24, but add to make minus 11. So at the side, what you could do is write minus 11 and 24. Writing down all the factor pairs of 24, so 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then I'm done. And you're looking for those pairs, can I add or take away to make minus 11? Well, I clearly can't do that with 24 and 1. I can do it with 12 and 2. No, can't do it. Can I do it with 3 and 8? Well, 3 plus 8 is 11, so yes, I'm going to be able to do it. And can I do it with 4 and 6? Nope. So how do I do it with 3 and 8 to make minus 11? Well, I need minus 3 and minus 8 to make minus 11. And just double check at the end. Minus 3 times minus 8 is 24. So I've done it right. Minus 3 minus 8. So we've got two brackets that equal 0. That means that x minus 3 equals 0, or x minus 8 equals 0. And just solving those equations, x must be 3 because 3 take away 3 is 0, or x must be 8 because 8 take away 8 is 0. And we're done there.
Question 12, simplify this algebraic fraction. So remember, when we're simplifying, we need to factorise the top or bottom or both. So let's factorise the top. Common factor for top. So I've got 2a is the common factor times b plus 2 times 3 is 6. So 3. There's my top. The bottom is a difference of two squares. So I just double bracket straight away. B and b, minus in one bracket, plus in the other, 3 and 3. I've chosen to put my plus in the second space to make it more obvious for you. You'll notice now you've got the same on the top and bottom. B plus 3 and b plus 3 cancel. So that leaves you with a final answer of 2a over b minus 3. Answer for factorising the top, then the... Question 12. Express that as a single fraction in its simplest form, algebraic fractions. X plus 2 squared. So x plus 2, and it's a divide. So the first thing we're going to do is get rid of that divide. So we've got 4 over x plus 2. Divide means we change to our times, and we flip the second one upside down. And now we can simplify and advance as normal. So we've got x plus 2 and x plus 2 on top and bottom, so I can take one of them away, and that just leaves x plus 2. And then we can answer the question. You've got 4 times x plus 2 over 5. And we're done. No need to expand the bracket because it's already simplified. It doesn't make it any simpler.
Simplifying algebraic fractions, SQA National 5 Maths 2019, Paper 2, Question 15. Express 4 over x minus 2, take away 3 over x plus 5 as a single fraction in its simplest form. So, this works exactly the same way as fractions when you're adding them before or taking away. You need a common denominator. Now, the easiest way to get a common denominator, especially with algebraic fractions, is times the bottoms together. So I can put brackets around these. My common denominator is going to be this. So as a single fraction, I'm making it nice and long, I've got x minus 2 times x plus 5 on the bottom. Now to get your tops. Well, you can think of it as this fraction's been times by this. So I need 4 times x plus 5. And this fraction's been times by x minus 2. So I need minus 3 times x minus 2. Or a quick and easy way to think of this, especially last minute, is I'm crossing over like this. So it's 4 bracket x plus 5. Make sure you've got your brackets around there. Minus, because it says minus, 3x minus 2. And there's your fraction. So now you need to simplify that. So we're going to expand the top. So expanding the top, we get 4x plus 20, 4 times 5, minus 3x. And what's your minus times a minus? That gives you plus 6. And we've still got our x minus 2, x plus 5. There's no need to expand the bottom. So that gives you 4x minus 3x is 1x. 20 plus 6 is 26 over x minus 2, x plus 5. And just double check, once you've done this, can you factorise that? No, you can't, so you can't simplify any further. There's nothing else you can do. So we're done there. And finally, for functions, National 5 Maths 2022, Paper 1, Question 2, just last year. F of x is x cubed minus 2. Find f of minus 3. F of minus 3 equals minus 3 cubed, take away 2. Minus 3 cubed, well, 3 times 3 is 9, times 3 is 27. So that gives me negative 27, take away another 2, which is negative 29. National 5 Maths 2018, Paper 2, Question 6. A function is defined as f of x is 5 plus 4x. Given f of a is 73, calculate a. So this is the one where you have to solve an equation. So we've got 5 plus 4a, because it's changed the letter, equals 73. Taking away 5 from both sides, 4a equals 73, take away 5. That gives you 68. So a is 68 divided by 4. And again, you can just calculate for this one because it is a calculator paper. But 4 goes into 6 once. 4 sevens is 28. You would get 17 as your final answer. The next question says, a function f of x is defined as f of x is 2 over root x. Express f of 5 as a fraction with a rational denominator. So we're coming in with surds here, but we're still the same point for part 1 for 1 mark. All you have to write is f of 5 equals 2 over root 5. And then working that out with surds, times the top and bottom by root 5 to rationalise the denominator. We get 2 root 5 on the top over 5 on the bottom, and that is as simple as it's going to get. So we're
find the equation of a line passing through those points and give it in simplest form. So we need the gradient first. So gradient is y2 minus y1 over x2 minus x1. So that's x1, y1, that's x2, y2. So that gives me 7 minus minus 1 on the top, and minus 5 minus minus 3. That gives me 8. Minus 5 add 3 is minus 2. That gives me minus 4. Now we use y minus b equals mx minus a, or y equals mx plus c. So I'm going to just pick a point for a and b. I'll just pick the second one, a and b. Y minus 7 is minus 4 x minus minus 5. Watch out for minus minuses. Y minus 7 is minus 4 x plus 5. Y minus 7 is minus 4x minus 20. So y equals minus 4x minus 20 plus 7 is minus 13. And we're done. Line of best fit, SQA National Maths 2019, paper 1 question 6 had this one. It says the fuel consumption of a group of cars is recorded and the scatter graph shows the relationship between the fuel consumption, F on the y-axis, kilometres per litre, and the engine size, E in litres of the cars. The line of best fit is drawn. Find the equation of the line of best fit in terms of F and E. Give your equation in simplest form. And then for part B, engine size 1.1, use your equation to find the kilometres per litre he should expect to get. So part A first, straight line question. We need 2 points to find the gradient, and then y minus b equals mx minus a. Now it's not told us any points here, so we need to go up to the graph and find them ourselves. So you just look for real points on the graph. So don't pick this, that's not on the graph. Don't pick this. Don't pick this that you can't read. Look for one you can read. There's one there, and there's one there. So our first point I'm going to use is this one, and that is looking here 3.54, so it's along 3.5 and up 8. So I can take a note of that here, 3.5 and 8. And similarly, this one here I can see is 1.5, 14. Once you get your 2 points, you can work out your gradient. So remember, gradient is y2 minus y1 over x2 minus x1. So I'll call that x1 and y1, and this one x2 and y2. So we've got 14 take away on top over 1.5 minus 3.5. Now I should be expecting a negative answer here because the slope is sloping down the way. So 14 take away is 6, 1.5 minus 3.5 is minus 2, which gives me a gradient of negative 3. 6 divided by negative 2. Then we're going to use y minus b equals mx minus a. So I'll just call one of the points a and b. Let's do this one, but you can use the other one. So y minus b is mx minus a. So we've got y minus 8 equals minus 3x minus 3.5. Get a mark for getting that far, and then fixing it all up. Y minus 8 equals minus 3x. Minus times a minus is a plus. 3 times 3 is 9, plus 1.5 is 10.5. And then that means y equals minus 3x plus 18.5. But we need to swap our axes for f and e. So f equals minus 3e plus 18.5. for our final mark. Part B says use your equation to work out how many kilometres per litre he gets, which is F, and his engine size is 1.1. So for part B, E equals 1.1. So that means that F equals minus 3 times 1.1 plus 18.5. That equals minus 3.3 plus 18.5. And if you can't do that sum, you can just at the side do 18.5 minus 3.3 to get 2. 8 minus 3 is 5 and 1. So you get 15.2. And the units were given to us, kilometres per litre. Kilometres per litre. And we're done there for our final mark.
Okay, 2018, paper 2, question 14 says, a straight line has equation 2x minus 5y equals 12. Find the point where it crosses the y-axis. So there's our equation, crosses the y-axis when x is 0. So we've got 2 times 0 minus 5y equals 20. So we've got minus 5y equals 20, divided through by minus 5, y is minus 4. So the point is 0 minus 4. That's the 5 maths. 2014, paper 1, question 11 says, a straight line has equation 4x plus 3y equals 12. Find the gradient of the line. Well, that's quite easy then. So we just rearrange it to make y the subject. So we've got 4x plus 3y equals 12. So taking the 4x over to the other side, we get minus 4x plus 12. Dividing through by 3, we get minus 4 over 3x. Plus 12 divided by 3 is 4. And then stating our gradient m must equal minus 4 thirds. And we're done there. Part B says find the coordinates of a point where the line crosses the Part B says find the coordinates where a point crosses the x-axis. So we've got 4x plus 3y equals 12, remember. Cuts the x-axis when y is 0. So we've got 4x plus 3 times 0 equals 12. So 4x equals 12. So x is 12 divided by 4, which is 3. So the point is 3, 0, x and y. Okay, a little bit harder this one. 2022, paper 1, question 15. A triangle and rectangle are shown. Find an expression for the area of the triangle. So the area of a triangle is a half the base, which is 3, times the height. Don't be worried that the height is algebraic, x plus 12. So that's an expression. We can simplify that a little bit. That's 3 over 2, x plus 12. And that is a fine answer, but I'll go ahead and multiply out the brackets. We get 3 over 2, x. 12 divided by 2 is 6 times 3 is 18. So there's my area of my triangle there for our mark. And then part B says, given the area of the triangle is equal to the area of a rectangle, find the value of x. So we already know the area of a triangle is 3 over 2, x plus 18. And that equals the rectangle, this times this. So in other words, 6 times 8 minus x. If we can get that far, then we're good to go. We just need to solve our equation, okay? So let's start working on this. We've got 3 over 2x plus 18 equals 48. 8 times x is 6x. Times and through by 2, I'll write that here, 3 over 2x plus 2 times 18 equals 2 times 48 minus 2 times 6x. Make sure you times everything by 2. So that gives me 3x plus 2 times 18 is 36. 2 times 48 is 96. And 2 times 6 is 12. So we get to a simple-ish equation, moving the x's to the left-hand side. We get 15x by adding 12 plus 36 equals 96. So 15x equals 60. Dividing through by 15, we get x equals 4. National 5 Maths 2019, paper 1, question 14. Solve this equation. So again, the lowest common multiple between 2 and 5 is 10. So if I times everything by 10, I'll be good to go. So I've got 10 times x over 2 minus 10 times 1 equals 10 times 3 minus x over 5. Simplifying our fractions, we get 10 over 2 is 5, so that gives me 5x minus 10 equals 10 over 5 is 2. And now we can solve the equation as normal. 5x minus 10 is 6 minus 2x. Taking the x's over to the left, adding 2x gives us 7x minus 10 equals 6. So 7x equals 16. And therefore, final answer is x equals 16 over 7. Check that it's simplified. It is, so I'm done. Solving inequalities. SQA National 5 Maths 2018, paper 2, question 4. Solve algebraic Venn equation 3x is less than 6, bracket x minus 1 minus 12. So it's just the same as solving equations, but sometimes there's an adjustment to be made at the end. So let's just write the 3x is less than 6 times x minus 1, because I'm expanding the bracket. And then I've got minus 12 sitting about in the end. So that's 3x is less than, well, 6 times x is 6x. 6 times minus 6 is minus 6. So I've got 6x minus 6 minus 12. Collecting the terms together, 3x is less than 6x minus 18. Tip for you here. Keep your x's positive. So it doesn't matter what side they end up on, but if you end up with a negative x, it means you're going to have to divide by a negative, which means you're going to have to do something weird about flipping the sign, which is a bit funky. So just keep your x's positive. So I'm going to move the x's over to this side. So that becomes minus 3x on both sides. and that means I'll just leave it like that for now to get 0 is less than 3x minus 18. So I need to add 18 to both sides to get rid of the 18 from the x's. 18 is less than 3x. Divide through by 3 to get 6 is less than x. And that's a fine answer. You can leave your answer like that. Or if you prefer, reading it backwards, you'll have x is greater than 6 because it's going backwards. Now, if you had put your x's on this side, you would have been divided by a negative, and this sign would have flipped into that sign. So either option's fine. Linear inequalities. Let's look at some past paper questions. National 5 Maths 2017, paper 1, question 8. Solve algebraic inequality, and then it's shown. So these, you just treat these the same as equations, but sometimes you have to change the sign. We'll get to that in a minute if we need to. So we've got 19 plus x is greater than 15. Multiplying out the brackets, we get 3x take away 6. Now, with inequalities, it's always best just to leave your x's over. It doesn't really matter which side, but leave them positive, because if you ever get a negative x, then you have to flip the side, which you don't want to do. So the smallest x's is on the left, so I'll move them to the right. So I've got 19 is greater than 15. 15 take away 6 is 9. So 9. 3x minus x is 2x. And then we can move the 9 over, so we get 10 is greater than 2x. So dividing through by 2, we get 5 is greater than x. And that is an acceptable answer. But a lot of times your teachers may tell you to change that so that the x is always on the left. If you wanted to do that, then you would just read it backwards. X is less than 5, so the sign changes to less than instead of greater than. But the first answer I gave you is fine as well. So 5 Maths 2018, paper 1, question 3. Solve algebraic with a system of equations. So as you say, it's the same thing over and over again. We've just to solve them by the same way, make the x's of the y's the same. So in this time, I'll make the y's the same again. So I'm going to times this one by 2 and times this one by 5. This will give me 10 for both of them. So that gives me 8x plus 10y equals minus 6. 30x minus 10y equals 25. The signs in front of the y's are different, so I can add the equations. I'll just put an add here. 38x equals 25 take away 6, which is 19. So x is 19 over 38. Always simplify your fractions. 2 19s is 38, so that's just a half. And now we substitute into any of the equations we've got to get our y. The top one, remember, was 4x plus 5y is minus 3. So x is a half, so I've got 4 times a half plus 5y equals minus 3. A half of 4 is 2, plus 5y equals minus 3. So 5y is minus 5. So y is minus 1 for our second answer. And we're done there. Okay, National 5 Maths 2017, paper 1, question 13 was a picture, but it gave you the 2 equations as well. It says the graph shows 2 straight lines with these equations. The lines intersect at point P. Find algebraic with coordinates of point P. If it mentions point of intersection, that means solving simultaneous equations. That's a key thing to realise. So I just need to solve both of these equations simultaneously. So if I look at my 2 equations, I've got 3x minus y and x plus 3y. So I could times one of these by 3 to make the x's the same, or times this one by 3 to make the y's the same. This time I'm going to make the y's the same. So just times in this one by 3. I can write down the new equations I get. So the first one I'm going to get is 9x minus 3y equals 6. So I can write that, 9x minus 3y equals 6. And the second equation is staying the same, x plus 3y equals 19. So I'll call that equation 1 and equation 2. And this time you can see that these numbers are the same but they're different signs. So I add the equations when they're different signs. So I do 1 plus 2. So 9x plus 1x is 10x. The y's disappear. 19 plus 6 is 25. So x is 25 over 10. Leave that as a simplified fraction if you want, or a decimal, because it's an easy decimal. I would write 2.5 for this one. Okay, and then we need to substitute in to get our y. So just pick a simple equation. I'm just going to pick x plus 3y equals 19, because there's only one x there. So I've got 2.5 plus 3y equals 19. So 3y equals 19 minus 2 is 17, minus 0.5 is 16.5. And just checking, this was a paper 1 question, yep. So I need to divide through by 3. 3 5s are 15, leaving 1. 3 5s are 15 again, 5.5. So we've now got our two numbers, 2.5 and 5.5, but it's to find the point, the coordinates of P. So I need to change that to a coordinate, an x and a y. So our final answer is 2.5 and 5.5. And we're done there.
Simultaneous equations for question 4. After writing an equation, 4 mangoes and 3 apples, 4 mangoes, 3 apples equals £4.25. Quite standard. Part B, 5 mangoes plus 2 apples equals £4.70. I have to find the cost, part C, of a mango and an apple. So I've got my two equations. We've got 4m plus 3a is £4.25. And we've got 5m plus 2a is £4.70. Times the top by 2 and the bottom by 3, just to get 6 in the second position. So that gives me 8m plus 6a equals 8.5, and it gives me 15m plus 6a equals 3 7s is 21, 3 4s is 12, 13, 14.10. I'll call that equation A and B, and we're going to do B minus A because the signs are the same and it's easy to do 15 take away 8. 15 take away 8 is 7m, £14.10 minus £8.50. Well, you can just use a calculator for that. That gives you 5.6, which means dividing by 7, m is 0.8. Let's call this one equation 1 at the top. We're going to substitute that into equation 1 to find our a. So sub into 1. So let's just remind ourselves of the equation. We've got 4m, so it's 4 times 0.8 plus 3a equals 4.25. That gives you 3.2 plus 3a is 4.25. So taking away 3.2, 3a is 1.05, and dividing, of course, by the 3, we get a equals 0.35. Not answered the question yet though. We need to say a mango and an apple equals. So a mango equals £0.80. Or 80 pence, and an apple equals £0.35 or 35 pence.
22, paper 1, question 7. Change the subject of the formula to b, but there's a fraction. The first thing is it's divided by c squared, so times both sides by c squared. So first step, dc squared equals b plus 4. And now we can just take away 4 to get b. So we've got dc squared minus 4 equals b, or if you prefer, b is dc squared minus 4. And that's a nice 2-mark question. Changing the subject of the formula, let's look at linear ones first, so no squares or square roots to do, just ones where you're going to have to manipulate it as a normal standard equation almost. So the first one, 2019 paper 1 question 7 said, the area of a trapezium is given by this formula, make x the subject of the formula. So key things we here are, if there's brackets, you need to expand them. If there's fractions, you need to get rid of them by times them by the denominator. Doesn't matter which order you do it first. I usually get rid of fractions as fast as I can. So I'm going to times both sides of this equation by 2. So in step 1, I'm going to write 2a on the left-hand side equals, well, 2 times a half is 1. So h x plus y is all that's left. And now we can expand our bracket. 2a is equal to h times x plus h times y. And we have to make x the subject. So the goal is anything with x gets left on its own. So I need to move this to the left-hand side. So I've got 2a minus hy equals hx. And I want x on its own, so I need to divide through by h. So 2a minus hy all divided by h equals x. Or you can write it the other way. X equals 2a minus hy all over h would be fine as well. Paper 1, question 14. Change the subject of the formula to x. But again, we've got a root involved. Now, when it's a root, but if there's other things in the question, it's sometimes better to make the root the subject and then square at the end. It just eliminates any problems you're going to have. So I'm going to make the root x the subject. So I'm going to take away h to start with. So y minus h equals g root x. Dividing by g, we get y minus h over g equals root x. And now, since we've eliminated everything and we've got root x on its own, we're going to square both sides. So we can just write a big bracket, y minus h over g squared. The whole thing's getting squared. Equals x. And we're done. Okay, changing the subjects, but when there's squares and square roots involved. So this is 2016 paper 2, question 12. Change the subject to k, but there's a square root. So I'm going to have to eliminate that square root. Well, the opposite of a square rooting is to square. So I'm just going to square both sides. So that gives me L squared. And when you square a square root, this root just disappears. So it gives me 4kt minus p, whatever's under that root. Now I can change it to k in the same way, adding p to both sides. I get L squared plus p is 4kt. Dividing through by anything which is attached to that k, which is 4 and t this time, we get L squared plus p all over 4 and t equals k. Or you can write it the other way, k equals L squared plus p over 4t.
Question 5 says express x squared plus ax plus 15 in the form x plus a squared plus b. This is called completing the square. A half the middle number, immediately take it away. I've still got plus 15 in the end, so I've got x plus 4 squared minus 16 plus 15. So I've got x plus 4 all squared minus 16, add 15 is minus 1. Hence, the otherwise state the coordinates of the turning point of the graph. Well, completely square form tells you the turning point, it is 4, but then it's the opposite, so it's minus 4 and then minus 1. So we've got minus 4, minus 1, job done.
Okay, completing the square in the quadratic formula. SQA National Maths 2018, paper 1, question 19. Quite a big one this. Part A, express x squared minus 6x minus 18 in the form x minus p squared plus q minus p squared plus q or minus a squared plus b, completing the square. Then state the axis of symmetry, which we'll get to, and the roots of this can be expressed in this form. Find algebraic D and E. So this is a quadratic formula question in a paper 1. We've expressly put it like that because that's what it looks like at the end or before you've got your answer. So let's go through this step by step. Question A. I've got x squared minus 6x minus 81. So to complete the square, I go like 1 bracket squared, x minus half the middle term is 3. Now, how do I get my numbers on the end? Well, I'd immediately take off that number squared. So the number is take away 3 squared, technically minus 3 squared. Then you're going to still take away 81 because that's hanging around on the end. So that gives me x minus 3 squared. 3 3s are 9, so it's take away 9, take away 81. Because I'm over by 9 basically. So that gives me x minus 3 squared minus 9 minus 81. That's minus 90. And we're done there. Part B, 10 state the equation of the axis of symmetry. When you complete the square, we don't do it for nothing. It tells us something. It tells us the turning point. The turning point is this number here and this number here. That sign changes. So if it's minus, it becomes positive. Positive becomes minus because you're making this bracket 0. So my turning point is 3 minus 90. I'll just write that down. My turning point, which we may ask you in some questions, is 3 minus 90. When you draw a quadratic, it is symmetrical at the turning point. So when they ask you for the axis of symmetry, we're just asking you for x equals 3 because it's a vertical line, so x equals the number. Where does 3 come from? The turning point. So that's all we're asking you there. Part B says, the roots of the equation x squared minus 6x minus 81 equals 0 can be expressed in the form x equals d plus or minus d root e. Find the values of d and e. There's 2 ways to actually do this. You can start from completed square form, or you can go back and use the quadratic formula. I think most people will use the quadratic formula rather than the completed square form, so I'm going to do it that way. But just be aware you can do it the other way. So let's start off with x squared minus 6x minus 81 equals 0. If we look at the start of the exam paper, it says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So our a equals 1, the number in front of x squared, our b equals minus 6, and our c equals minus 81. X equals minus 6, watch there's a minus and a minus there, plus or minus the square root of minus 6 squared minus 4 times 1 times minus 81 all over 2 times 1. So watching out for minuses. Minus 6 is positive 6, plus or minus the square root of 6 times 6 is 36, minus times a minus is a plus. 4 times 81, well, you might need to do that sum at the side, but if you have to, just do this. 4 ones is 4, 4 eights is 32. So that, and it's a minus times a minus, so it's a plus. So it's plus 324. 2 times 1 is 2. We have to get it down to d plus or minus d root e. So x equals 6 plus or minus the square root of 324 plus 36. So that's 324, 330, 360 over 2. Well, 360 is like a surd, yeah? You may not know if it's an exact square root, but we can work it out as a surd because we can do root 360, 2 numbers at times together to make that, well, 36 and 10. So that means you get root 36 is 6, root 10. Now, root 10 can't be simplified further, so I can change my root 360 to 6 root 10. So x equals plus or minus 6, plus or minus the square root of 6, root 10 over 2. So that means that x equals, dividing the first thing by 2, I get 3, and the second thing by 2, I also get 3 root 10. And we're done there. Complete the squaring parabolas. SQA National Maths 2017, paper 1, question 14. The graph shows a parabola with the equation of the form x plus a squared plus b. That's called completing the square, remember. The equation of the axis of the symmetry of the parabola is x equals minus 5, as shown. State the value of a. So this is testing. Do you know that this tells you that? It does. It tells you the turning point. The a is the 5. So all we're asking you to do is write a equals 5, not minus 5. Because it's what makes this bracket 0. So it's 5 here. So it's minus 5 plus 5 is 0. So it's just 5. So a equals 5. It now says the point 3 minus 8 lies on the parabola. Calculate the value of b. So we've got x now equals, x plus 5 squared plus some number b. But we know the point lies on, so we're going to substitute the point in because that's an x value and that's a y value. So a is our y equals minus 3 is our x plus 5 squared plus b. So a equals minus 3 plus 5 is 2 squared plus b. 2 squared is 4 plus b. It should be clear that b must then equal 4 because 4 plus 4 is 8. If it now asked us what the turning point was, we would also know the turning point. It would be 5, 4, because that's exactly what completing the square does.
Question 13 says, sketch a graph of y equals x plus 1x minus 3 using the axes provided below. And on our sketch, we need to show the points of intersection with the x-axis and y-axis and the turning points. So notice this is already factorised. So our roots are given straight away, x plus 1. So we've got x equals minus 1 and x minus 3. So we've got x equals positive 3. So we can immediately put that on, minus 1, and I'll make my 3 sit here, where it cuts the y-axis. So for the y-axis, we need to make, remember, x equal to 0. So we've got 0 plus 1, which is 1. I'll write it out actually. And 0 minus 3. So that's 1 times minus 3, which is minus 3. So again, on my y-axis, I can go down and say minus 3. I now just need my turning point. So my turning point is in the middle of the roots. So middle of minus 1 plus 3 is this, add them and divide by 2. 3 minus 1 is 2 over 2. It happens at x equal to 1. So at x equal to 1, y equals, substitute it back into our equation, 1 plus 1, 1 minus 3. That equals 2 times minus 2, which is minus 4. So our point is 1 minus 4. So we can note that. Let's go along to 1. Let's note minus 4. So it's about here. Make a nice, neat sketch. Remember, it's going to be a parabola. So we go down here, through our axis, round and back up. And that will do. And I'll just to be on the safe side, I'll note that that point is 1 minus 4. And we're done.
Okay, completing the squaring parabolas. SQA National Maths 2016, paper 1, question 10. Sketch a graph of y equals x minus 3 squared plus 1. Show clearly the coordinates of the turning point and intersection of the y-axis. Well, the turning point is easy. TP, turning point. It is simply the opposite of this number, which is 3, the opposite sign, and then the second number 1. Why is it the opposite? Because it's what makes this 0. 3 take away 3 is nothing. Okay, where it cuts the y-axis. Cuts the y-axis when the other letter x equals 0. So just subbing that in, we get y equals 0 minus 3 squared plus 1. That's minus 3 squared plus 1. 9 plus 1 is 10. So the point is 0, 10. Or you can remember that you just do that squared plus that, always when it's in complete square form to get where it cuts the y-axis. So now we can just draw a little picture. An x and y-axis, it's just a little sketch. So we're going to cut at 10, so I'll just note that. And our turning point is 3, 1. So we can go 3, along 3, up 1, say, is there. and then just draw a nice, neat parabola and label that point nice and neatly 3, 1, and we're done there. SQA National 5 Maths 2019 Paper 1 Question 9, completing the square. The graph shows a parabola. The maximum turning point is 420. Write down the equation of the axis of symmetry. So the axis of symmetry, remember, is this line that goes down the middle. That's a vertical line, so that occurs at x equal to 4 because the coordinate is 420. So remember, the turning point tells you how to find this in completed square form. So the completed square form is the turning point. A is minus 4 because it's the opposite to make that 0. So A equals minus 4 because minus 4 plus 4 is 0. And B is just your 20, the other number. So it's minus 4 and 20.
Mr. Cleland here from Cleland Maths. So another hard question that we're going to look at this time from a National 5 paper. It was a 2016 paper 2 question 12. So a good few years ago, but quite a common type of question to come up. And it says, the diagrams below show a rectangle and triangle. All measurements are in centimetres. Find an expression for the area of a rectangle for 1 mark. Then, given the area of a rectangle equals the area of a triangle, show that x squared minus 2x minus 8 equals 0 for 3 marks. Then find algebraically the length and breadth of a rectangle for 3 marks as well. Have a look at this and see if you can get anywhere with it before we come back and discuss it and see what the solution is. Okay, so what this question is asked us to do is find an expression for the area of a rectangle, which we'll do in a moment, but essentially it turns into a quadratic question. But also it is going to be, you're going to have to find the expression for the triangle, make them equal to each other, and then rearrange that equation to get that quadratic. Quite a hard skill. Once you've done that, you'll then have to solve your quadratic equation. I'm going to go through a few steps with this and a few pointers that I think might make this a little bit easier, especially if you can't do the whole question. Okay, part A, find an expression for the area of a rectangle. Don't be scared by this. You all know the area of a rectangle is length times breadth. So just write down what the length of a rectangle is. If it was a number, you would write down 4, 5, 6. But in this case, it's x plus 8. So I'll just write down x plus 8. Now, since this is going to be times by something else, I'll put that in brackets. And I need to times by the breadth for the height, which is 2x plus 1. 2x plus 1. So there is an expression for the area of my rectangle for 1 mark. Part B, given that the area of a rectangle equals the area of a triangle, show that this. Now, we'll try to get there, but we don't know how to get there. But it does say area of rectangle equal area of triangle. So we know the area of a rectangle is x plus 8 and 2x plus 1. And that equals the area of a triangle, where a triangle is half times the base, 2x plus 5, times the height, 3x. So we can write they equal to each other. So now we need to expand some brackets, and we'll get marks for expanding the brackets if we've managed to write this down. So expanding the left-hand side, I usually use a box. We get x plus 8 on one side and 2x plus 1 on the other side to get 2x squared plus 16x plus 1x plus 8, and that equals a half times 2 is 1. So that's 3x times 1 times x plus 5. So essentially it's a half times 2 is 1, leaving just this to expand. That gives me 3x squared plus 15x. Tidying up the left-hand side, we get 2x squared plus 17x plus 8. And that equals the right-hand side of 3x squared plus 15x. You would get a mark for expanding this bracket and a mark for expanding that bracket. And then a mark for making them equal to each other and then somehow getting it down to the expression that they want. Now, the expression they want is equal to 0, so I need to move everything over to the same side. So I've got small 2x squared, so if I look at the right-hand side, I've got 3x squared plus 15x. I'm going to make this 0. I'm going to take away 2x squared then. I'm going to take away 17x, and I'm going to take away 8. So 0 equals 3x squared minus 2x squared, which is x squared. 15x minus 17x is minus 2x, and I've got minus 8. Or to put it in the way we want, x squared minus 2x minus 8 equals 0. Now you couldn't get very far with this question if you couldn't do part A, and if you could even do part A but you couldn't write down an expression for the triangle or just didn't know what to do, you couldn't do part B. That doesn't stop you doing part C though, because part C then says, hence find algebraic with length and breadth of the rectangle. And the question already told you that x squared minus 2x minus 8 equals 0 in part B. So even if you've lost the first two parts, you can still, if you know how to factorise and find out x, work out this from using quadratics. Okay, so you either got a quadratic formula or you've got factorising. Now, since this is non-calculator, you can bet 9 times out of 10 we're going to factorise. So let's have a look at it. We have got x squared minus 8x, 2x minus 8 equals 0. You're looking for, just to factorise this, numbers at times there to make 8. So I've got 1 and 8 or 2 and 4. And I want to pick the pair that add or take away to make minus 2. Well, 1 and 8 never does it, so it's going to have to be 2 and 4. And then I just write down, how does that make minus 2? Well, it makes minus 2 by doing, it's not going to be 4 take away 2 because that's plus 2. It's going to be 2 take away 4. Or plus 2 take away 4 is minus 2. And plus 2 times minus 4, just to check, is minus 8, which is the last number. So I can now factorise it. And a lot of this you could have done without any working. X and x. I've got plus 2 in one bracket and minus 4 in the other. You get a mark for factorising. And then for solving, you can then say x plus 2 equals 0 or x minus 4 equals 0. So that gives me that x equals minus 2 or x equals 4 for a second mark. And then, because this is a question in context and we're talking about actual lengths of the triangle and rectangle, if we go back up and look at the lengths, we've got x add 8 on the rectangle. Well, that means that we've got 4 plus 8 and we've got minus 2 add 8. And then on the other side, we've got 2x add 1. So that's 2 times 4 is 8 plus 1 is 9. But then you'd have, if you use the minus 1, minus 2 plus 1. Minus 2 times 2 is minus 4 plus 1, which is minus 5. So we can't have a negative x because it's going to give us a negative height or breadth. And that doesn't work. We can't have a negative length. So we have to pick the one that's going to work. So using x equal to 4, the length is equal to, so remember back at our triangle, eight plus 4, which is 12 centimetres. The breadth was 2x add 1, so 2 times 4 plus 1, which is 9 centimetres. And we get our final mark for working that out. It's been Claire Maths today. We've looked at another hard National 5 Maths question, this time from 2016, paper 1. Hopefully that was helpful for you. Take care, stay safe, and goodbye.
Mr. Clare here for Clare Maths. This one was from 2019 paper 1 National 5 Maths, and it was asking a question about a ball getting kicked off a cliff, and it asked us when will the ball hit the sea. Bit of a strange one, that one. So let's have a look at this one and see how we solve that one. Again, it's an unfamiliar context, so that is what makes it difficult. So here's a picture of the actual question. It says a ball is kicked from a cliff top and its height is given by this equation. H is 12t minus 5t squared. Part A, calculate the height of the ball above the cliff top after 2 seconds. Have a look and see if you can solve that. Then part B, continued the graph below represents the height of the ball relative to the cliff top after t seconds. It says the sea is 17 metres above the cliff top. After how many seconds will the ball hit the sea? Have a look, see if you can solve that. Okay, the solution to the first problem. Calculate the height of the ball after 2 seconds. Well, we've got an equation. The height is 12t minus 5t squared. and they want t equal to 2 because it's 2 seconds. So it's just a substitution question in an unfamiliar context. So the height would be 12 times 2 minus 5 times 2 squared. That's 24 minus 4 5s is 20. So that gives me an answer of 4 meters for 1 mark there. Okay, part B, this gives us the graph relative to the cliff top after t seconds. The sea is 70 meters below. After how many seconds will the ball hit the sea? Well, just remember our equation for the height was equal to 12t minus 5t squared. But we know that this must equal minus 17 because it's going down by 17 from the start. So that means we just need to say that that equaled 17 minus 17 for 1 mark. And that's difficult to see if you're not sure of the context of the question. Part 2 then says once we've got our equation, we just need to solve that equation in a normal way. So this is a quadratic. So if I move everything to the right hand side, I'll get 0 on this side. I'll get 5t squared minus 12t minus 17, or in the more familiar way, 5t squared minus 12t minus 17 equals 0. So that's a quadratic that we can now solve. There are 2 main ways to solve a quadratic. We can use the quadratic formula or we can factorise. Now, since this is a non-calculator paper, chances are that this will factorise. I'm going to show you my method for factorising at this point, see how you can follow along. So what I do, if I use a different coloured pen, if I times 5 and 17 together, 5 times 17, well, that equals 5 7s is 35, 5 1s is 5, so that means 85. I'm looking for factors of 85, okay? There's not many options, but we need to add or take away to make 12. So let me start listing them in order. I've got 1 and 85. Well, they don't add or take away to make 12, the middle number. 2 clearly doesn't go into it. 3 doesn't go into it. 4 doesn't go into it. The next one it goes into it is 5, because it ends in 5. 5 and 8 goes 1. 3 left over. 5 7s is 35. Now, if you look and stop here for a moment, you should realise that 5 and 17 times together to make the 85 that I've just found out, but they add or take away to make minus 12. So remember, now we're just trying to make minus 12. So to make minus 12 is our key number. That equals minus 17 plus 5. So if we draw a box at this point, we have got 5t squared, and then we're splitting up our middle term into minus 17t plus 5t, that gives us my minus 12t, and then at the end, I've still got my minus 17. So now we can just factorise each line and column. So factorising this, 5t squared and minus 17t, the only common factor is t. But going up and down the way, the common factor between 5t squared and 5t is clearly 5t. Now it's like a Sudoku puzzle. T times minus 17 is minus 17t, so it's minus 17. And 5t times 1 is 5t, so it's plus 1. My factors have dropped out. So in the end, after all that work or any method you prefer for factorising, you get 5t minus 17, and you get t plus 1, and that equals 0. And if you can get to that part, you can get a mark there. Final thing to do is to solve that and work out your t's. So for the first one, you've got, from this one, you've got 5t minus 17 equals 0. That means that t must be 17 over 5 seconds. And then the other one, you've got t plus 1 equals 0, so t must be minus 1 seconds. But time is positive, so t minus 1 is invalid. So there is our final solution. 17 over 5 seconds is the one we're selecting as our final answer.
Question 7, solve the equation 4x squared plus 2x minus 7 equals 0. Give your answer to two significant figures. Since it's telling me to round it and it's a quadratic, I know that I'm going to have to use the quadratic formula because it won't factorise if the answers need rounded. So we're going to check the start of our exam paper again, find the quadratic formula. I'll write it here, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a equals 4, b equals 2, and c is negative 7. So we just substitute everything in. So that gives us minus 2 plus or minus the square root of 2 squared minus 4 times minus 7 all over 2 times 4. Minus 2 plus or minus the square root of, so we can do a bit in brackets first, 2 squared minus 4 times minus 7. That's 116. Just watch out for the minus times a minus, over 8. So remember we split that into two sums, minus 2 plus root 116 over 8, or minus 2 minus root 116 over 8. Get a calculator, work out both sides. First answer gets 1.096, or about 1.1. And the second answer, I get minus 1.596, and a bunch of numbers, or if I wanted to round that, minus 1.6. The two significant figures for both of them. And that's me done. I've rounded it 4 marks.
SQA National Maths 2015, paper 2, question 14, the quadratic formula. A rectangular piece of card measuring 9 by 13 is placed on a rectangular piece of card. The area of the card is 270, the border x wide all the way around. Write an expression for the length of the card in terms of x. What a lot of people find this difficult, but if we look at this length here, it's going up x, then up 13, then up another x. So I've got 2x plus 13 is the answer to that. 2x plus 13. Hence show that 4x squared plus 44x minus 153 equals 0. Doesn't make much sense, but this is going to be an area question, so we're just going to work out the area and see where we go from there. So we have got 2x plus 13 on one side, and then if we go along the other side, we know that that is also x plus 9 plus x, so 2x plus 9 on the other side. I'll just write that up here, 2x plus 9. But it tells us the area of the card is 270, so I can immediately write down for part 2, that 2x plus 13 times 2x plus 9 must equal our area, which is given as 270. And then we'll just expand the brackets and see if we get what they got. So expanding those brackets, we've got 2x times 2x is 4x squared. We have got 2x times 9 is 18x. And then looking at the 13 part, we've got 13 times 2x is 26x. And then we've got 13 times 9. 13 times 9 is 117, but you can use a calculator for that. And that still equals 270. So collecting our like terms, we get 4x squared. 26x plus 18x is 44x. And then we've got plus 117, but that equals 117, but that equals 270. So taking the 270 over to the other side, take away 270 both sides, 117 minus 270 is minus 153, but you can use a calculator for that. So you get 4x squared plus 44x minus 153 equals 0, which is what it asked us to do. Then part B says calculate x, the width for the border. Well, we have now got a quadratic equation that we can solve. And even if you couldn't do part 2 for 2 marks, you can still go ahead and do this because they give you the equation. It's a calculator paper, so it's a quadratic formula question. So let's start working on that. For part B, we've got 4x squared plus 44x minus 153 equals 0. Our quadratic formula, remember from the start of the exam paper, is minus b plus or minus the square root of b squared minus 4ac all over 2a. So a is equal to 4, the number in front of x squared, b is equal to 44, the number in front of x, and c is negative 153. So subbing everything in, we get x equals minus 44, plus or minus the square root of 44 squared, minus 4 times minus 153 all over 2 times 4. And if you did that, you get a mark just for the substitution, and then a mark for working out the bit underneath the square root, the discriminant. So x equals minus 44 plus or minus the square root of, in your calculator you do 44 squared, and then 4 times 153, and you might remember to add them together because it's a minus times a minus. If you do that, you get 4384. And that's over 8. So now we have got two answers. We've got x equals minus 44 plus the square root of 4384 over 8. And we've got x equals minus 44 minus the square root of 4384 over 8. So getting our calculator out and working that out, you do minus 44 plus the square root, get an answer divided by 8. You'll get x equals about 2.77. And for the other one, minus 44 minus the square root, then divide by 8, you'll get minus 13.77. But remember, x is the width of the card, so we cannot pick a negative answer because you can't have a negative width. And therefore, to one decimal place, our final answer is x equals 2.8. And the units were centimetres, so we could write centimetres. And we're done there. Using the discriminant, SQA National 5 Maths 2018, paper 1, question 8. Determine the nature of the roots of the function f of x equals 2x squared plus 4x plus 5. If it mentions nature of the roots, you're using the discriminant, which you'll get from the start of the exam paper. If you look at the quadratic formula, the bit under the square root sign is b squared minus 4ac. That's called the discriminant. So our a is 2, our b is 4, and our c is 5. Signs are important. So b squared is 4 squared minus 4 times 2 times 5. That's 16. 4 2s are 8, 5s are 40. 16 minus 40 is negative 24. And then we need to write a little statement. And the statement is always since b squared minus 4ac, this one is less than 0, there are no real roots. There are two options when you do this. If you get 0, there are 2 equal roots and 2 real equal roots. And if you get a positive number, there are 2 distinct real roots, 2 different real roots. Okay, right, there we go.
SQA National 5 Maths 2019 Paper 2 question 13 on gradient. Find the expression for the gradient of a line joining A is 6,9 to the point B is 4p and 4p squared. Give your answer in its simplest form. Don't worry if it was algebra in this question. You can still just do it using the gradient formula and you'll just have an algebraic answer. So A is x1 and y1, and then we've got x2 and y2. So m is y2 minus y1 over x2 minus x1, which equals 4p squared minus 9 on the top, and x2 is 4p minus 6 on the bottom. You'll get a mark just for substituting it in, but then we need to tidy that up so it's now become algebraic fractions. So we can factorise the top and maybe the bottom and then work on it there. So 4p squared minus 9 is a difference of 2 squares. So that is double brackets, square root of 4p squared is 2p, the square root of 9 is 3, so it's 2p and 3 in both brackets, plus in one, minus in the other, all over. And 4p minus 6 has a common factor. The common factor would be 2, so I can take 2 out as a common factor. 2 times 2 is 4, so it's 2p. 2 times 3 is 6, so it's minus 3. you get a mark for factorising the top. And then we can go ahead and cancel down to get our final answer. So 2p minus 3 and 2p minus 3 can be cancelled to leave us with 2p plus 3 all over 2 for our final answer. On arc length, 2022 National 5 Maths Paper 2 question 10. An attraction at a theme park has a carriage attached to an arm as shown in this picture. The arm swings from A to B along an arc of a circle centre C as shown below. The length of the arm is 15 metres and the length of the arc is 69.4. Calculate the size of the reflex angle ACB, in other words this angle here. So it's just arc length because it's length of arc. So I'll just write down what I know. Arc length equals angle over 360 times pi times diameter. Substitute everything in. So my arc length is 69.4. That equals my angle, which I don't know, over 360 times pi times 30, because 2/15 is 30. And you'll get a mark for substituting in. And then we need to rearrange it in the same way we've been doing. So I start off with, to get my angle, 69.4. Divide by everything that was on top, pi times 30. Times by everything that was on bottom, 360. So then we can just work that out in a calculator by doing 69.4 times 360 divided by brackets pi times 30, and you will get an answer of 265.08 or 265 degrees. And that is 3 marks. SQA National 5 Maths 2019 Paper 1 Question 4 had this arc length question. It says the radius is 30, the angle is 240, calculate the length of the major arc. Now this was paper 1, so it's non-calculator, so I'm going to give you some hints for this one. You still start off in the same way, don't be worried. Arc length equals angle out of 360 times pi times diameter. Now we can just substitute in. Our angle is 240 out of 360 times by pi times by 60. Double 30 makes 60. So now at this point, you might be wondering, what can I do? Well, to calculate this with a non-calculator, always best to simplify any fractions first. So I'm just going to take it beside 240 over 360. I can drop the zeros to straight away to get 24 over 36. And then I'm looking for two numbers at times together to make 24. A number that goes into 24 and 36. Well, 4 goes in, I know that straight away, so I'll divide by 4. 4 6s is 24, 4 9s is 36. Oh, I can see 3 goes in as well. And you could have got there quicker by dividing by 12. 3 2s is 6, and 3 3s is 9. So our sum now can be replaced with this fraction. I've got arc length is 2/3 times pi times 60. I'll leave the pi to the end. So I've now got 2/3 of 60. So I divide by 3 and times by 2. 3 20s is 60. 20 times 2 is 40. So I've got 40 times pi. So that's 40 times 3.14. So we need to do this sum. So there's lots of ways to do it, but times them by 40 is the same as times them by 10 and times them by 4. So again, at the side, you can just do 3.14 times 4. 4 4s is 16, carry 1. 4 1s is 4, plus 1 is 5. 4 3s is 12. So you get 12.56. So that is 10 times 12.56, which is 125.6. And our units were centimetres. SQA National 5 Maths 2017, Paper 2, Question 14 on arc length. The diagram shows part of a circle, centre O. It says the radius is 6.4. The length of the major arc is 31.5. Calculate the size of the reflex angle AOB, in other words, this angle here. So we're just using arc length again and working backwards. So we'll just write down everything we've got. So arc length, I'll just write AL equals angle over 360 times pi times diameter. We've got the arc length, that's 31.5 on the left. We've not got the angle, so I'll just write theta or x or anything you want over 360 times pi times, now be careful, the diameter is not 6.4, that's the radius, so I double that to get the diameter of 12.8. Now if you can get that far, you get a mark. Angle over 360 times pi times 12.8. And then we need to work backwards. So again, remember, we start with this. So our angle equals 31.5, and I'm going to divide by everything on the top, pi times 12.8. And we're going to times by everything on the bottom, 360. Then we get a mark if we can get that far. And then for a mark for our final answer for calculating our angle theta, when we do 31.5 times 360, divided by brackets pi times 12.8, is 282.003, or to a reasonable degree of accuracy, 282 degrees for our final answer. SQA National 5 Maths 2018, Paper 2, Question 2 on arc length. The diagram below shows the sector of a circle, centre C. It shows the radius is 7.4, the angle is 320, and it asks us to calculate the length of the arc. So this is a straightforward one. We can just write down arc length equals angle over 360 times pi times diameter. Always write down your formula first. Your angle is 320. We've got that over 360. And we're timesing by pi, and our diameter, well, it's told us 7.4, so we need to double that, so that is 14.8. Get a mark for writing down our formula. We get a mark for getting our angle, 320 over 360, our fraction, 320 over 360. We get a mark for our final answer, which worked out at 41.32. Centimetres. And we're done there. SQA National 5 Maths 2016, Paper 1, Question 3 for area of a sector. The diagram shows a sector of a circle, centre C, and the radius is 20, the angle is 45. Calculate the area of a sector without a calculator. So we'll start off with the same way. Area equals angle out of 360 times pi r squared, and we calculate that by putting 45 out of 360 times pi times 20 squared. 2 marks so far, 1 mark for getting the fraction and 1 mark for substituting in, and now we just need to do lots of work to get the actual answer for our final mark. So fractions, we simplify. So 45 into 360, well, 45 goes into 360 8 times, so I get 1/8 times pi. 20 times 20 is 400, so I do an 8 for 400 is 50 times pi, and then again you can just at the side do 3.14 times 5. 5 fours is 20, 5 ones is 5 plus 2 is 7, 5 threes is 15. You get 15.70, so that gives you, that's times by 5, so it's 10 times 15.70, which is 157 centimetres squared for our final answer. Another quick way at this point would be to times by 100 and then divide by 2. SQA National 5 Maths 2018, Paper 2, Question 17 says, in the diagram below, AOD is a sector of a circle with centre O and BOC is a triangle. In the sector AOD, the radius is 30 centimetres and the angle is 75 degrees. So we've got AOD, we know that this bit here is 30 centimetres. And it also says in the triangle OBC, O to B is 38, so this whole bit's 38, so we know that we could put a wee 8 here, I suppose. And we know that O to C is 55, so we can draw that in there and say that that's 55 centimetres. What is it asking us? Well, it's asking us to calculate the area of the shaded region. So this is a combination of area of a sector, which is why it's in here, and area of a triangle, which is in the trigonometric section. So let's start off, we can do any one you want, but it's going to be a takeaway, because if I do the whole area of a triangle, I get all the area shaded in, but then I need to take away the area of the sector to get this shaded bit here. So it's a takeaway triangle minus sector. So let's do area of a triangle first. From the start of the exam paper, the area of a triangle is a half AB sine C. So that's 0.5 times, well, remember it's the angle and the two sides either side of the angle. So it's this side 38 and this side 55. 38 times 55 times the sine of 75 degrees. You put all that into your calculator and you get an answer of 1009.39. Bunch of other numbers, centimetres squared. So you've done your triangle, you get a mark for that. You now need to do your sector, so let's go back to our sector work. So we've got angle out of 360 times pi times r squared. So let's write that. Area of sector is our angle out of 360 times pi times, and we need to identify our radius, so let's go back up. The radius is just 30 centimetres, so it's 30 centimetres squared. So you get a mark there for identifying your fraction, and you get a mark for writing down fraction times pi times 30 squared. And if you work it out in a calculator, you get 589.04 centimetres squared. So far we have got 3 marks. There's 2 more marks. The next mark is for working out, you need to do the triangle minus the area and writing that down. So our shaded area is equal to our 1009.39 minus our 589.04. And we get a mark for just writing that down, and then a mark for our final answer, which is about 420.3 centimetres squared. And also I'm putting ... because I've not rounded, but 420 would be fine, or 420.3 centimetres squared would be fine as well. SQA National 5 Maths 2016, Paper 2, Question 7. A carton is in the shape of a large cone with a small cone removed. So it's a takeaway. The large cone has a diameter of 32 and a height of 24. The small's got a diameter of 18 and a height of 13.5. Calculate the volume of the carton, and again, rounding involved to 2 significant figures. So we do the volume of the big cone minus the volume of the small cone. So let's just do that, right? So the volume of our big cone is, remember, volume of a cone is 1/3 pi r squared times h. Given at the start of the exam paper, 1/3 times pi times, now the radius is going to be 16 because it's half the diameter, and the height is 24. So we get a mark for doing that and getting an answer. The answer to that would be 6433.98 with a bunch of other numbers, centimetres cubed. Now we do the small cone. The volume of the small cone, 1/3 times pi times the radius, which is 9, half of 18, squared, and times the height of the small cone, which is 13.5. We put all that in our calculator and we get 1145.11 and a bunch of other numbers, centimetres cubed. So we've got one answer, 2 answers for 2 marks. And then we get a mark for knowing that we need to take away. So our volume is equal to 6433.98 minus 1145.11. And that gives us, using the unrounded figures to take away, 5288.87. And then we get, for rounding our final mark, 2 significant figures it says. So that equals 5300 units, centimetres cubed, for 5 marks. A volume question, SQA National 5 Maths 2017, Paper 2, Question 6. It says a spherical sweet is made coating caramel sphere evenly with chocolate. A cross-section sweet is shown. The diameter of the sweet is 22 millimetres and the thickness of the coating is 3 millimetres. Calculate the volume of the coating. So the volume of the coating is not a full shape, so it's a takeaway again. So I need to do the volume of the big sphere minus the volume of the small sphere, and that will give me what's left in between. So it's a takeaway. So let's do our big sphere first. The volume of a big sphere, remember from the start of the exam paper, 4/3 pi r cubed. 4/3 times pi, and the radius, well, we need to do a bit of maths here, I suppose. If I draw a dot out here and go to here, well, that's half of 24, which is 12. So it's 12 cubed. And that gives us 7238.229. 7238.229 millimeters cubed in this case. Now the volume of our small sphere is 4/3 times pi, and the radius of a small sphere, well, let's do a bit of maths up here. So I need to go from the middle to here. Now we already know that this bit is 24, but the coating is 3. So if I take away 6, 3 from either side, 24 minus 6 is equal to 18. 18 divided by 2 for the radius is equal to 9. We get 9. So it's 4/3 times pi times 9 cubed. In a calculator, we get 3053.628. So that means the volume of our coating is equal to 7238.229 minus 3053.628. That gives an answer of 4184.601, which when rounded to 3 significant figures, I think, in this question, well, that means I need to go 1, 2, 3 and round here, so it's 4180. 4180 millimeters cubed for our final mark. Now, a volume question, SQA National 5 Maths 2018, paper 1, question 17, had this one. A square-based pyramid is shown in a diagram. The square has a base length of 6, and the volume is 138. Calculate the height. So this is a working backwards volume question. So math stages, there's a few ways you could do this, but math stages is always to write down my formula, then work backwards. So from the start of the exam paper, the volume of a pyramid is 1/3 times the area times the height. Okay, so substituting everything in, I've got 138 on this side equals 1/3 times, now it's a square, so it's 6 squared or 6 times 6. I'll just write 6 squared times the height. Stage we can do 138 equals 1/3 of 36 times h. 138 equals, well, 3 into 36 goes 12, so that's just 12h. And then we can work out h. 138 divided by 12 is equal to 11.5 centimetres. And that is one of the simplest ways to work it out. You could have also just made h the subject of the formula and worked it out, but there you go. 2022, paper 1, question 3, paper 1, non-calculator for a change. It says, the diagram below shows a cone with diameter 20 and a height of 60. Calculate the volume, take pi as 3.14. Well, first thing we do is write down the volume of a cone, which is 1/3 times pi r squared times h. Okay, so substituting everything in, that's 1/3 times 3.14 times r is 10, half the diameter, and the height is 60. Now, whenever I'm doing a non-calculator volume question or anything with pi non-calculator, I'll leave the 3.14 as late as possible to the end. I'll do all the other sums first, and then hopefully it'll be easier. So you get a mark for that, and then your final mark is just for getting the answer. So you need to do all the work to get the answer to get 2 marks. Don't worry if you can't get 2, 1's good enough getting that substitution in there. So doing the work, I've got 1/3 times 3.14 times, well, 10 times 10 is 100. So I've got 100 times 60, that's 6,000. So then I'll do 1/3 of 6,000. Well, 3 goes into 6 twice, so that gives me 2,000. So I've got 2,000 times 3.14. So at the side, I can do 3.14 times 2, double in a number, 8, we get 2, we get 6. So we get 6.28. So that gives me 6.28 times 1,000. That's 6280 centimetres cubed. For our final mark. A train tunnel has a circular cross section with a horizontal floor, and here's the diagram below. Calculate the height of the tunnel. Clearly, to me it clearly is a Pythagoras question. It's asking me for the whole height. Well, I know the radius from here to here, but I don't know this bit. So if I fill in that bit first, if I just draw a line down, make a right angle, then we've got 2 here and 2.9, so we can do I'll call this x. X squared is going to be 2.9 squared minus 2 squared. That gives me 4.41. So x is the square root of 4.41, which is exactly 2.1. So I now know that that's 2.1 using Pythagoras, and then we've got this extra bit here. But that extra bit there will be 2.9 because it's a radius. So our total height just equals 2.9 plus 2.1, which is exactly 5 metres. SQA National 5 Maths 2019 Paper 2 Question 18 had this question. It's a cartoon snowman, and it's got a lot of information about the head is a small circle with centre S, and the diameter of that from here to here or here to here is 15. The large circle has got a centre of T, and it also lies on the circumference of this one. And A and B lie on the circumference of both circles. Calculate the height of the snowman. It was quite difficult. But if we notice, we know this line here is 15, so we're really just being asked to calculate the radius of the big circle. Now we can calculate it anywhere. So if I go inside this bit from here to the outside, that's a radius of the big circle too. I'll draw that in. And we already know of some facts. We know that'll make a right angle, but we know that the diameter of the small circle is 15, so that is 7.5, but so is this. So taking that outside of the circle, just to be clear, we have got 7.5 here and 7.5 here with a little x here. So x squared is 7.5 squared plus 7.5 squared. So that means that x equals the square root of 7.5 squared plus 7.5 squared, which we can calculate and then square root or just use brackets to get about 10.6. So that means now that our height is just, well, let's just double check. It's going to be the diameter to T, which is 15, plus the radius of the big circle, which we've just worked out is 10.6. That gives you 25.6 centimetres. 2019, Paper 2, Question 11, Converse of Pythagoras. The diagram shows a jet ski race. The course is marked out by markers A, B and C. It says B is 600 metres from A, C is 650 metres from A, and C is due north of B. Determine whether B is due east of A. Well, if it is, it will be a right angle. Now, you cannot use Pythagoras to get this missing side because you're going to try and prove it's a right angle. So we'll start off with the fact that the whole course is 1500. 600 plus 650 is 1250. We take that away from 1500 to get 250 metres, and we just mark that on. We know that's definitely 250. Keeping it all separate, we've got a left-hand side and a right-hand side. Our left-hand side is 600 squared plus 250 squared, and the right-hand side is 650 squared. Do not write they're equal, that's why I draw a little table and keep them separate. We then work out both sides separately. So the first sums gives us 422,500, and 650 squared, if you work that out in a calculator, also gives you 422,500. So then you can say, since 600 squared plus 250 squared equals 650 squared, then angle is right angled is a right angle. So we could then write what we're trying to say. A is east of B. B is east of A, sorry. And we're done. SQA National 5 Maths 2022 Paper 2 Question 11, another 3D Pythagoras question, and it's telling us that the length of the cuboid is 24, the breadth is 6, so there's my length and breadth, and the height is 8. Calculate the space diagonal from front to back. So it's just 3D Pythagoras, 24 squared plus 6 squared, the base, times the height, 8 squared. So I can write 24 squared plus 6 squared plus 8 squared all in one go. And then we can work out that by doing the square root of all of that. So we can do the square root all in one go, just put brackets around the sum, and you will get 26 centimetres. Moving on to 3D Pythagoras. SQA National 5 Maths 2018 Paper 2 Question 16. So this is often calculating a missing length in a 3D shape, usually with a space diagonal. Chris wants to store his umbrella in a locker. The locker is a cuboid with internal dimensions 40, 40 and 70. The umbrella is 85 metres long. He thinks it will fit in the locker from P to M. Is he correct? You should probably just put that umbrella in the locker and check himself, but let's do some maths. So we've got 40 by 40 by 70, and we want to calculate the space diagonal. So we're going to go from here, the front to the back. All you need to know is that you can do 40 squared plus 40 squared, and that will give you the diagonal of this, and then you use the diagonal of this with the height to get this, or all in one go, you can just write 40 squared plus 40 squared plus 70 squared. So that is our strategy. So whenever you're doing a space diagonal, it is the base numbers times the height, all squared, 3D. So then we need to square root that to get our answer. So it's 40 squared plus 40 squared plus 70 squared, all square rooted. If you do that, you get 90. And then just a little statement. His umbrella is 85, we got 90. So yes, because 85 centimetres is less than 90 centimetres. Done. SQA National 5 Maths 2018 Paper 1 Question 9 had this one, and it says the diagram is a regular decagon. You can count that. It's 10-sided. Okay, it's 10-sided. And it says KGL here is 17. You've got a straight line, A, K, and L. Calculate the size of KJL here. Okay, so we're going to have to do some work to get the angles. We're going to need to know this angle here. But all these triangles are the same. And since that's around a point, I can just do 360 divided by 10 to get 36 in the middle. So I know that that's 36 here, and that's an isosceles triangle. So 180 minus 36, it's paper 1, so you just need to do it with a calculator to get 144. 144 divided by 2 gives you 72 degrees. So we get 72 here and here, but since all these triangles are exactly the same, that means that that one's also 72. And now we've got angles on a straight line up to 180, so these two make 144, and I need to take that away from 180, so I get 36 back down here. And now it's pretty simple. Angles in a triangle add up to 180, so I do 36 plus 17 away from 180 is 127. So our answer is 127 degrees for our final mark. You get a mark for getting 72 and 72, or for getting 36 down there. Then you get a mark for the 127 at the end. National 5 Maths 2022 Paper 1 Question 4 had this diagram, and we have to calculate the size of ACE. So that goes from here to here to here. But as usual, I'll just start with the angle I'm given and work up to it. So I've got 68 here. So is this an isosceles triangle? Yes, it is. So I can do 180 minus 68. That is 120 minus 8, 112. So 112 divided by 2. 2 into 11 goes 5, 56. So we get 56 down this side. Now we can move on to our next triangle. Over here, angles on a straight line add up to 180. So 180 minus 68 is 112. And again, you should be able to see that that's an isosceles triangle on this side as well. So you can do 180 minus 112 to get 68, and then divide that by 2 to get 34. So you get 34 degrees up here. Tangent meets radius at right angles. So I now know that there's a right angle on this side, but also on the other side. So these two add up to 90. So I do 90 minus 34 to get 80, 70, 60, 56. And then identifying it, what we want me to go from here, A to C to E. So that is this angle inside here. So we didn't actually need that 56, we just need to know that was 90. 90 plus 34 is 124. So our angle is 124 degrees for our final mark. So we get a mark for getting 112 or for getting 56. We also get a mark for getting the 34, then a mark for adding 34 to 90 to get 1. 15 paper 1 question 3 said AC is a tangent to a circle centre O with point of contact B. D is the diameter, F is the point on the circle circumference. And it tells you 77 and it tells you 64, which is all in the diagram. And it calculate BDF. So I usually just start by calculating whatever I can really and just work my way down. So let's have a look at what we've got. First of all, I can see a tangent and a radius, so I know that that's a right angle on that side, but so it is on that side. So these two angles add up to 90. So 90 minus 77 gives me 13 degrees. And then I can start working inside this triangle. So that's a radius and a radius. I can just mark it on with little lines. So I know that the two angles at the bottom are the same size. So they're 13 each. So I can just mark that on. As soon as I've got two angles in a triangle, I can work out the third angle. So angles in a triangle are up to 180. So 13 plus 13 equals 26. So I do 180 minus 26, which is 154. So I've got 154 in the middle. But now we've got a straight line. So angles on a straight line are up to 180. So I'll just move to the next triangle. 180 minus 154 is 26. Now looking at this triangle and knowing everything else, or trying to, well, there's a radius and there's a radius. So I can mark that they're the same, and therefore at the bottom they're the same. So I can do 180 minus 26 is 154 and divide that by 2 to get 72. And then we can finally move on to our last triangle. A diameter making a triangle, so that is a right angle triangle. So I can put right angle here. And then we've got these three angles add up to 180. So I've got 64, 74, 84, 26 degrees. So we've got the one up here as well. And then we'll just check what's it asking for. BDF, B to D to F. So these two together. And then just write a little statement. Angle BDF equals 13 plus 26, which equals 39. Now going by the official mark scheme, you get a mark for getting 13 and a mark for getting 26 and a mark for adding them up. But I find the best strategy is just to try and find as many angles as you can, and at the end the angle will pop out, unless it's obvious what you're doing. SQA National 5 Maths 2022, Paper 2, Question 6 had this question. Calculate the area of this triangle. Again, it's exactly the same. There's my C, because that's the angle. So any other ones would be my A, opposites A, B, opposites B. Area is a half AB sine C. So that gives me 0.5 times 32 times 25 times the sine of 58 degrees. We get a mark for substitution, it's worth 2 marks, and then a mark for a final answer using a calculator. If we type 0.5 times 32 times 25 times the sine of 58, making sure we've got degrees, we get 339.21 square centimetres. 339 would be an acceptable answer, or 0.2 or 0.21. We have a triangle with trigonometry. This is given to you at the start of the exam paper. Just a reminder that it tells you that the area is a half AB sine C. And we're going to look at a bunch of questions that use this idea. So SQA National 5 Maths 2017 paper 1 question 7 had DE is 8, EF is 12, and sine of E is 2/3. Notice this is a non-calculator question, so it's telling you the sine of the angle so that you don't have to work it out already. So the main key point with this is the angle is always in between the two known sides to do the area. So that angle is always our C. So if I want to relabel it, I could call that C, and then that could be A, and that could be B, to give me my little A and my little b here. Well, it's just a substitution. The area is a half of 12 times 8 times the sine of E. Well, C we've called it now, so that would be called sine C. So that gives us 0.5 times 12 times 8 times the sine 2/3. I need to do some work here. 0.5 times 12 is 6. 6 times 8 is 48. So quite quickly we get to 48 times 2/3. And then if you divide 48 by 3, 3 goes into 4 one time. With 1 left over, 3 6 is 18, so that's 16 times 2. So a final answer of 32 square units, which is centimetres. And we're done there. Looking at the sine rule first of all. So we're going to look at a few National 5 questions and get into it straight away. A set of step ladders has legs 150 by 140, SQA National 5 Maths 2016, paper 2, question 8. When the step ladder is fully open, the angle between the longer leg and the ground is 66. Calculate the angle X, which is shown here. So we really don't need this picture. So a reminder of the sine rule from the start of the exam paper. You get A over sine A equals B over sine B equals C over sine C. You can just copy that. And basically it's pairs. So if I call that letter A, that goes with this one, which is A. I could call that B, and that goes with this one, which is B. And obviously there's nothing on the other one, so I can just ignore them. So I've got A over sine A, 140 over sine 66, equals B over sine B, 150 over sine X. And you will get a mark for that substitution. You can now rearrange that to make sine X the subject. So I always think of it as a cross. This times this, 140 sine X, equals this times this, 150 sine 66. So now dividing by 140, sine X is 150 times sine 66 over 140, and you would get a mark for that. And then your final mark for finding X. So you need to do the inverse sine, because they've got sine X, so X equals the inverse sine of 150 times sine 66 divided by 140. And you can do all that in a calculator in one step. Place inverse sine, open a bracket, 150 times sine 66 divided by 140, close your bracket, and you will get an answer of 78.18 or 78.2 degrees. If you prefer, you can work out the answer to that first and then do the inverse sine of just that answer to get the same thing. Just make sure you don't round too early. National 5 Maths 2019, paper 2, question 19 had this long question. So it says Katie and Mona are looking up at a hot air balloon. In the diagram below, K, M and B represent the positions of Katie, Mona and the balloon. So that'd be Katie, that'd be Mona, that'd be balloon. The angle of elevation of the balloon from Katie is 52, there it's shown there. The angle of elevation of the balloon from Mona is 34, there it's shown there. And the distance between Katie and Mona is 350. And it says, calculate the height of the hot air balloon above the ground. It's quite a hard question. It's why it's worth 5 marks. Notice it's not asking me to calculate any of these diagonals, it wants me the direct height. So I can draw in a direct height here to show this, just by drawing a straight line down. And that's the side it wants me to calculate. Do not be tempted to think that cuts this line in half. It does not. So I'm going to need to get one of the other sides in order to use the sine rule or to use SOHCAHTOA to get the height. So that's exactly what I'm going to do. I'm going to start off by using the whole triangle to get one of the sides. You can pick any one you want, okay? I'm going to calculate this one, but you could go the other way and calculate this one. So let me draw a little diagram for us, or take some notes on this one. If I draw that without all the information, it's sometimes easy to do this. You've got 350 down here. I've got 34 degrees here, 52 degrees here, and I want to calculate this side here. I'll call that A. So I'll call that like A. So I've got this pair, and I'll need another pair, but I've not got this one. So the first thing I'm going to have to do is get this angle at the top, because I need it to go with this one. So adding these two numbers together and taking away from 180. So 52 plus 34, that gives us 86. 180 minus 86 is 94, so I can note that is 94 degrees and start my work. Got A over sine 34 equals 350 over sine 94. And if you're going this route, you will get a mark for that. We now need to rearrange that. So A sine 94 equals 350 sine 34. So A must equal 350 times the sine of 34 over the sine of 94. So getting a calculator and working that out, you get A is 196.195, or 196.2 would be fine, or even just 196. So far I've got 3 marks: substitution, rearranging, and getting an answer. But now I need to get the height, okay? So redrawing my triangle to the side with all the information I've got now, I want this height here. I know that this bottom whole thing is 350. I've just calculated that this one is 196.2. And I know some angles. I know this is 52 degrees. This is 34 degrees. I'm not going to bother putting this on because it doesn't cut it in half. It adds up to 94, but it doesn't cut it in half. You can calculate either this angle or this angle using right angle triangles here. But there's lots of ways now to work out this height. The easiest way is to use the sine rule again. So we'll go ahead and do that. We have got, if I use a different colour, I'm going to use this one, goes with this one. And we're going to use this one, this is an angle B, goes with this one here. So we can just simply write A over sine 52 equals 196.2 over the sine of 90, because that's 90 degrees. Rearranging that, that implies that A times the sine of 90 equals 196.2 times the sine of 52. So A equals 196.2 times the sine of 52 divided by the sine of 90, which is 1, by the way. Just a note on this question: once you get to this point, that is a right angle triangle. You could have just used SOHCAHTOA to find A. I basically didn't, but I've just not bothered to do it for this question because SOHCAHTOA is a National 4 skill, but you might have forgotten. You don't need it at all in National 5. You can just keep using the sine rule, just use the sine rule twice and realise that this angle is 90 and you'll be good. By Maths for 18, paper 1, question 10. So this is a non-calculator. It says side x, z is 10, zy is 8, cos z is 1/8. Calculate xy. So it tells you the cos of z instead of the angle, so you don't have to work it out. But it's still cosine rule, because I've got two sides and the angle in between to find the opposite side. So if I just call that my A and that my A, I can just change that to an A. So then we've got A squared equals B squared plus C squared minus 2BC cos A. Substituting in, that is 10 squared plus 8 squared minus 2 times 10 times 8 times, well, the cos of A is 1/8. Non-calculator, so you're just going to have to do some non-calculator work on this, I'm afraid. 10 times 10 is 100. 8 times 8 is 64. Luckily, I've got 8 times an eighth, so that's 1. 1 times 10 is 10, times 2 is 20. So take away 20, which gives us a final answer of 144. But remember, that is A squared. So A is the square root of 144, which is a nice round number, which is 12 centimetres, because 12 times 12 is 144. SQA National Maths 2017 Paper 2 Question 3 had this question. It says PQ is 250, PR is 180, and this is the angle, and it's building a fence around this. We want to wish to build a fence alongside QR. What is the length of the fence? So we need to work out the length of QR. So once again, just checking, as long as I've got the angle in the sides, either side of the angle, I can use that to cosine rule to find the opposite side. So I'm going to label this side my A. We could even call that angle A if you want, just for the sake of it. And then that would be my side B and that would be my side C. Doesn't really matter which is which. So we write down the cosine rule from the start of the exam paper. We'll always go back and check it. B squared plus C squared minus 2BC cos A. Substituting in 250 squared plus 180 squared minus 2 times 250 times 180 times the cos of 147 degrees. Remember, we could do that in one step in a calculator. Put brackets around this, minus brackets around the whole of this, and you will be fine to go. And if you do that, or you take your time on it, you get 170,380.3, and that's A squared, remember though. So that's just got 2 marks so far, substituting and getting A squared. So now just calculate our A. The square root of 170,380.3, and you get an answer of 412.77 meters. 9. The diagram shows a triangle ABC. Calculate the value of cos B. Cos B? Trig. Start of the exam paper. Let's go. All the way back. It says the cosine rule, cos A is B squared plus C squared minus A squared over 2BC. Let me just write that down and copy it down for this question. So we're way down at question 9. So usually the cosine rule is written as cos A equals B squared plus C squared minus A squared over 2BC. And I was going to work at the value of cos B, which is here. So I'm just going to call that A, just to make that the one I want. And that means the opposite side is A, and the other two sides are B and C. It doesn't matter which is which, so I'll just call that B and that C and just substitute. As long as I make my angle A, I'm fine. So we've got cos A equals 7 squared plus 3 squared minus 5 squared over 2 times 7 times 3, 49 plus 9 minus 25, 2 7s is 14, 3 14s, 28, 38, 42. So that gives me 49 plus 9, which is 58. Minus 20, which is 38, minus 5, which is 33, over 42. Is that simplified? Well, numbers that go into both of them, I can divide by 3 to get 11 over 14. Now, We've written cos A, remember, but that's actually cos B. So our final answer, to be very clear for our examiner, cos B is 11 over 14. That's my answer. I want to change it to cos A and change the letters to make it make more sense to me, because we're using cos A as the formula. And finally, look at an example of using the cosine rule to find an angle. SQA National Maths 2019, paper 2, question 7 had this. It had a triangle with all three sides shown. Find the smallest angle in this triangle. Now, you may be wondering, how do I know what the smallest angle is? Well, it's pretty obvious just from the way it's drawn as well, but it is this one. So we'll use this as our smallest angle. So we'll relabel that A, and that'll be side A. And then the other two sides can be B, side B, and C, side C. Now, calculating the angle, I know to use the cosine rule because I'm given all three sides. From the start of the exam paper, cos A equals B squared plus C squared minus A squared all over 2BC. You don't need to remember that, you just need to be able to use it. So we'll just substitute all our numbers in, being very careful. So B squared is 8.5 plus 7.2 minus 6.3 squared. You're always taking away the one which is opposite the angle. All over 2 times 8.5 times 7.2. That's cos A. If you can get that far, that's a mark. So then we can do the inverse cos of our answer. Now, let's just tidy this up a little bit. If we work out our top, we get 84.4. If we work out our bottom, we get 122.4. Now, at this stage, you can either just divide them to get 0.689 or do the inverse cos of that fraction. It doesn't really matter what you do. And that means that A equals the inverse cos of 84.4 over 122.4. In a calculator, you get A is 46.4 degrees for your final answer. Okay, last one, 2018, paper 2, question 13. Hopefully you're getting the hang of this by now. A ferry and trawler receive a request for help from a stranded yacht. On the diagram, E, F, T, and blah. On the diagram, the points F, T, and Y show the positions of the ferry, the trawler, and the yacht. Ferry, trawler, yacht. It tells us lots of information in the bullet points. Just check that it's actually already in the diagram. So it says Fy is 7.2 kilometres. It is. Ty is 5.6. It is. Ft is 10.3. It is. And it says that F is on a bearing of 240 degrees from T. 240 degrees from T to F. Good. It says calculate the bearing of the yacht from the trawler. A little bit of a different question. This is asking us to calculate a bearing this time, not an angle. So the bearing of the yacht from the trawler. So that means it's asking us, really, starting at the trawler, go north, turn all the way around, past here, up to here, so I'm facing the yacht. That's what it's asking me to calculate. Don't worry too much if you're not quite sure what it's asking you to calculate, just start off in the same way. Although in this case, as soon as you see three sides of a triangle, you should be thinking cosine rule to get an angle. So it's really just identifying which angle it's asking for. So once more time, calculate the bearing of the yacht from the trawler, all the way around to the yacht. So I'm going to need this angle here. So let's just note this angle here. That's the one I'm looking for here. Cos A is equal to B squared plus C squared minus A squared over 2BC. So quite often, again, you'll probably just want to mark your angle as angle A so that you can substitute properly, or I'll always remember really that the one I'm taking away is opposite the angle and the other two are the ones that are adding. But let's just mark it A, so for clarity, so if I call that A, that is little a, and then the other two is going to be B and C, our sides. So we can then say we've got 5.6 squared plus 10.3 squared minus the 7.2 squared all over 2 times 5.6 times 10.3. That's cos A. You'll get a mark at that point for substituting correctly into the cosine rule. So there's a mark right there.
So for our next mark, if we can work out either that cos A is equal to, well, it's 85.61 on the top, over 115.36, or leaving that as a decimal, which would be something like 0.742, that gives us our second mark. Then looking at our third mark, calculating the angle. So A is the inverse cos of 85.61 over 115.36, or the inverse cos of this. And that gives me an angle of 42.008. 088, sorry. So there's our third mark. And then our fourth mark is for calculating the bearing. So just to remind you, the bearing is 240 plus this 42. So we can do 240 plus 42 is 282 degrees for our final mark.
2017, paper 2, question 10. In the diagram below, D, E and F represent the positions of Dunbridge, Aylesford and Fairtown respectively. It tells us that Dunbridge is 15 kilometres east of Aylesford, and it's drawn it in for us. From Dunbridge, the bearing of Fairtown is 126, which is drawn not to here, all the way round, north, down to Fairtown. From Aylesford, the bearing of Fairtown is 230. From Aylesford, 230 to Fairtown. Calculate the distance between Dunbridge and Fairtown. Calculate this distance. Let's just mark that up there with an X. No other information given. So again, the strategy is the same as before. We're trying to find angles inside the triangle, so we can use the sine rule or the cosine rule. Let's just start on this bit here. You've got north and east. That's clearly a right angle, so I can write 90 degrees. And then angles around a point add up to 360. So I can do 230 plus 90, which is 320, giving me 360 minus 320, which is 40 degrees. I can put 40 degrees inside this triangle there. On the other side, since it goes northeast, this bit also right here is 90 degrees. So that means these two add up to 126. So doing 126 minus 90, I get 36 degrees. So I've now got a second angle inside the triangle. Once I've got two angles inside the triangle, I may as well just find the third one, because chances are I'm going to have to use it. 36 plus 40, so let's just write that. 36 plus 40 is 76 degrees. 180 minus 76, because angles in a triangle add up to 180, gives us 104 degrees. So we can write that down here. And now we can check what it's asking us. To find a missing side. We've got one other missing side. So it's the sine rule, because for the cosine rule you would need this and this to get this. You've only got one side, so it must be the sine rule. So it's x over sine 40, opposites, x over sine 40 equals, and then the other side we've got is 15, and the opposite is 104. 15 over sine 104. A nice way to do this in your exam is to maybe get a different colour and just draw a line. These go together and these go together. Obviously, they would go together as well, the other two, but I can't use them because I don't need that. So, marks so far. You're getting a mark for 40 and 104 degrees. If you've managed to so far just calculate your angles inside your triangle, over here you've got a mark, and then you've got a mark for writing down the correct sine rule. Now we need to rearrange it. So, as per usual, we can say that x sine 104 equals 15 sine 40. So x is still 15 sine 40, but then divided by the sine of 104 degrees. And that's a mark at that point as well. And then our final mark, of course, just for working that out in a calculator, 15 times sine 40, then divided by sine 104, you get an answer of 9.936. Or if you're rounding, 9.9 would be fine. And the units are still kilometres. Try not to forget your units. In National 5, there's one question where they will mark the units. They won't take marks off for forgetting the units in all questions, but there's one question you can never tell which one it's going to be, so just make sure you do your units. Part of the graph of a sine bx is shown. What is a and b? Well, the amplitude, the height, is 3 minus 3, so a is just 3. State the value of b. Well, it's not 1. There is only one shown, but it only goes up to 45. I need to go all the way to 360. So you're basically asking how many 360s are in 45, how many 45s are in 360s? (45, 90). 180 will be 4. So you've got 8. In other words, b equals 8. There will be 8 of those graphs up to 360. SQA National 5 Maths 2019, paper 1, question 13 had this. Part of the graph 3 cos x plus 45 is shown. The graph has a minimum turning point A. What's the coordinates? So, if I kind of annotate on top of this, our normal cos graph, I'll put it at the side, goes like this. And it goes between 1 and minus 1, and this number here is usually 180. So that turning point is related to this turning point. It's usually along 180 and down minus 1. But this has been shifted to the left by 45 degrees. So 180 minus 45 will give me my first number, which is 135. And instead of it being minus 1, well, the amplitude is 3, so it's going to be minus 3 for our second mark. National 5 Maths 2015, paper 1, question 6 said the graph of part of y equals a sine x bx is shown. State the values of a and b. So number in front means the amplitude, so I'll go up, it goes up to 4 and down to minus 4. So straight away I can just write down that a equals 4, just like that. To get the other number, if it's a bx like this, it tells us how many waves up to 360. So I've got 1, 2, 3 waves up to 360. I'll do that again. 1, 2, 3 waves up to 360. So b equals 3 for the second mark. SQA National 5 Maths 2022, paper 2, question 9 had 3 sine x plus 4 equals 6. So taking away 4 for both sides, we get 3 sine x degrees equals 2. And therefore sine x degrees equals 2/3. So then we can find the inverse sine. You've got a mark already. So the inverse sine of 2/3, you do the inverse sine of 2 divided by 3 in a calculator, and you get 41.8 degrees. And then you need to find your second value using your cast diagram. So sine was positive, so it's a and s. So I need to do 180 minus 41.8 degrees, and that gives us 138.2 for our second mark there. And one turbine has 3 blades as shown, and it gives you this equation for the tip of the blade, and it says calculate the height of the tip of the blade when it's turned for an angle of 60. So I have to substitute 60 in. So for part A, I can just write h equals 40 plus 23 cos 60. That's 40 plus, now the cos is 60, use your calculator as 0.5. So you would get 0.5 times 23, which is 11.5. So you get a final answer of 51.5 metres. Part B says the minimum height of the tip of the blade A above the ground. Now this is a little bit tricky to think about, but we've got an equation here. 40 plus 23 cos x. Now if you think of a cos graph or anything else, you'll realise that the minimum the cos goes down to is minus 1. So it's really just asking you to realise that, and you've got h would then be 40 plus 23 times minus 1, so minus 23, which is equal to 17 metres. Now, if you're going to do part A and part B, don't worry, we only have 1 mark. Part C is the meat and potatoes of this. Calculate the values of x for which the tip of the blade is 61 metres above the ground. So, for part C, h is equal to 61. So I can write 40 plus 23 cos x equals 61 and solve that equation. So taking away 40 for both sides, 23 cos x equals 21. So cos x is 21 over 23. So then we can work out x. X is the inverse cos of 21 over 23, which is 24.1 degrees. But that's not the only answer, remember, because if we draw a cast diagram, we've got A and C, which is 360 minus, so we could have x is also equal to 360 minus 24.1, which is 335.9 degrees. SQA National 5 Maths 2022, Paper 2, Question 13. Another trigonometric identity question. Simplify sin x plus 2 cos x over cos x. Okay, so we could split this up into 2 separate fractions. We've got sin x degrees over cos x degrees plus 2 cos x degrees over cos x degrees. And then we can deal with each fraction individually. You get a mark just for separating them out, by the way. Sin x divided by cos x we know equals tan x. Cos x divided by cos x, well, that just simplifies to 1, that we cancel, so I've got plus 2 left over for our final answer. SQA National 5 Maths 2019, Paper 2, Question 17. Expand and simplify sin x plus cos x all squared. So it's a double bracket question as well. So I've got sin x plus cos x times sin x plus cos x. And expand that any way you want using a grid or foil. I'm just going to use foil for the sake of quickness. So first, sin x times sin x is sin squared x. Outside, sin x cos x, so it's sin x cos x. Inside is cos x sin x, but I'll just write sin x cos x to keep the order the same. And cos x times cos x is cos squared x. So that's your first mark there for getting your expansion, and then for tidying it up. So we need to tidy this up somehow. So we've got sin x plus sin x cos x plus sin x cos x. That's 2 lots of sin x cos x. But we've also got sin squared plus cos squared. If you remember our trig identity, sin squared plus cos squared equals 1. So that all simplifies to 1 plus 2 lots of sin x cos x for our final answer. Mean and standard deviation, SQA National 5 Maths 2022, Paper 2, Question 5. School netball team recorded a number of sit-ups each player completed in a minute. The numbers for the 7 players were this. Calculate mean and standard deviation, and then there's a comparison question to do at the end, but let's do part A first. So for part A, just recall from the front of the exam paper, the standard deviation is the square root of the sum of x minus x bar squared all over n minus 1. You could use the other formula, but I never do. So I'm just going to draw my table. My table goes x minus x bar from the start of the formula, and then x minus x bar again squared. And the goal here, remember, is I put all my x's down the side, I then take away the mean, I then square and get a final total which replaces the top of the formula. So the first thing we're going to do is calculate the mean by adding all these up. So let's just get my calculator ready. 182 is our total. So our mean, which we can just say is x bar, is 182 divided by 7, because there's 7 numbers, which is 26, and we get a mark for calculating the mean. So now in the middle, we take away 26 from each of the numbers. So we get 29 minus 26 is 3, and then we get 27 minus 26 is 1, and then minus 2, and then 5, and then minus 4, then minus minus 7, and then 4 again. Squaring each of the numbers, you get 9, you get 1, 2 2s is 4, 5 5s is 25, 4 4s is 16, 7 7s is 49, and 4 4s is 16. 9, 1, 4, 25, 16, 49, and 16 gives you another mark for getting that column. We then add all these up. 120, and that's our key number because now our standard deviation is equal to the square root of 120 divided by 6 because there's 7 numbers, so 1 less is 6. Square root of brackets 120 divided by 6 is 4.47, or 4.5 if you prefer. I'll just leave it as 4.47. And that's us done. We've calculated the mean and standard deviation. Let's move to part B. So some players in the school's hockey team also recorded the number of sit-ups they completed in a minute. They gave them mean as 29 and standard deviation is 3.2. Make 2 valid comments comparing the number of sit-ups of the players in the netball and hockey teams. So comparing the mean first, we always have to say on average. So I'm just going to write that down straight away before I have a look. And the netball team's mean was 26. The hockey team is 29. So on average, the hockey team completed more sit-ups. In a minute. And we could say because 29 is bigger than 26. So there's a mark there, and then comparing the standard deviation, which is all about consistency. The netball's team was 4.47, and the hockey team's 3.2, which means the hockey team was more consistent because it's a smaller number. So we just say the number of sit-ups was more consistent for the hockey team. And we could say because 3.2 is less than 4.47. Now be very careful with this one. You have to mention the number of sit-ups for the second standard deviation to get your mark, because you need to show that you know what. Interquartile range question, this time at SQA National 5 Maths 2019 paper 1 question 5 says the midday temperatures in Grantford were recorded over a 9-day period and they were here. Calculate the median and semi-interquartile range. So this one we do have to calculate the median, and then we'll have to make 2 comments about that, which we'll get into when we get there. So remember, median and semi-interquartile range, we need the data to be in order. So let's start with that. I've already put in the data in order for us, and we need to find the middle of that. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 1 is 10. The median happens at 5. 1, 2, 3, 4, 5. So there's my median right here. And I'll put the answer properly in a minute. Let's use a different colour pen. So the upper quartile is the middle of the upper half, which is this 4 numbers. So it's in the middle here. So I'll draw a little line. There's my upper quartile. Well, the middle of 7 and 9, no work required there is 8. If you didn't need some work on that, you just do 9 plus 7 is 16 divided by 2. The lower quartile then is the middle of 3 and 4. Well, that's 3.5. Again, if you didn't know that, 3 plus 4 is 7 divided by 2 is 3.5. So we can write that out in nice and neatly. Upper quartile is equal to 8. Lower quartile is equal to 3.5. My median was equal to 5. And the question asked us for the semi-interquartile range. Now remember, in National 5 from now on you'll get asked for the interquartile range, but I'll do the semi as well. So the interquartile range is just 8 take away 3.5, upper minus lower, 4.5. But to answer the questions for this paper, the semi-interquartile range is just half of that. So 4.5 divided by 2, which is 2.25. Let's move on to the comparison statements, which work the same way for interquartile range or for semi-interquartile range. Over the same 9 period, the midday temperatures in dock were also recorded and the median was 8 and the same interquartile range was 1.5. Make 2 valid comments. So this is a bit like when you did standard form. Median is the same as mean, basically. You're using on average. But for interquartile range, that's the same as standard form. You're using consistency there. So let's start off with median and then consistency. So let's take a note of the numbers we need. So I'll just take a note of this one and go down below. Part B, on average, our median in Grantford was 5, but in NDoc is 8. On average, the temperature in NDoc are higher, since 8 degrees C is bigger than 5 degrees C. The temperatures in NDoc are more consistent, since 1.5 is less than 2.25. So more consistent, smaller interquartile range, just like standard deviation. Line of best fit, SQA National Maths 2019, paper 1, question 6 had this one. It says the fuel consumption of a group of cars is recorded and the scatter graph shows the relationship between the fuel consumption, F on the y-axis, kilometers per litre, and the engine size, E in litres of the cars. The line of best fit is drawn. Find the equation of the line of best fit in terms of F and E. Give your equation in the simplest form. And then for part B, engine size 1.1, use your equation to find the kilometres per litre he should expect to get. So part A first, straight line question. We need 2 points to find the gradient, and then y minus b equals mx minus a. Now it's not told us any points here, so we need to go up to the graph and find them ourselves. So you just look for real points on the graph. So don't pick this, that's not on the graph. Don't pick this. Don't pick this that you can't read. Look for one you can read. There's one there, and there's one there. So our first point I'm going to use is this one, and that is looking here 3.54, so it's along 3.5 and up 8. So I can take a note of that here, 3.5 and 8. And similarly, this one here I can see is 1.5, 14. Once you get your 2 points, you can work out your gradient. So remember, gradient is y2 minus y1 over x2 minus x1. So I'll call that x1 and y1, and this one x2 and y2. So we've got 14 take away 8 on top over 1.5 minus 3.5. Now I should be expecting a negative answer here because the slope is sloping down the way. So 14 take away 8 is 6. 1.5 minus 3.5 is minus 2, which gives me a gradient of negative 3. 6 divided by negative 2. Then we're going to use y minus b equals mx minus a. So I'll just call one of the points a and b. Let's do this one, but you can use the other one. So y minus b is mx minus a. So we've got y minus 8 equals minus 3x minus 3.5. Get a mark for getting that far, and then fixing it all up. Y minus 8 equals minus 3x. Minus times a minus is a plus. 3 times 3 is 9, plus 1.5 is 10.5. And then that means y equals minus 3x plus 18.5. But we need to swap our axes for f and e. So f equals minus 3e plus 18.5 for our final mark. Part B says use your equation to work out how many kilometres per litre he gets, which is F, and his engine size is 1.1. So for part B, E equals 1.1. So that means that F equals minus 3 times 1.1 plus 18.5. That equals minus 3.3 plus 18.5. And if you can't do that sum, you can just at the side do 18.5 minus 3.3 to get 2. 8 minus 3 is 5 and 1. So you get 15.2. And the units were given to us, kilometres per litre. Kilometres per litre. And we're done there for our final mark. SQA National 5 Maths 2018 Paper 1 Question 6 for line of best fit. The cost of a journey for Tom's taxis depends on the distance travelled. The graph below shows the cost in pounds for P for a journey in Tom taxis and distance D. A is this point and B is this point. Find the equation of a line in terms of P and D. Give you equation in simplest form. So it's always the same straight line. We need gradient, then we need to use a point for y minus b equals mx minus a, and then we swap the y and the x for P in this case and D. And in part B, we got cost of journey of 5 miles. I substitute 5 in and see what I get. So part A, our points are 8 and 14 and 12 and 20. So that's my x1 and y1. And that's my x2 and y2. So my gradient is equal to 20 minus 14, y2 minus y1, over 12 minus 8, x2 minus x1. 20 minus 14 is 6, 12 minus 8 is 4. So you get 6 over 4. You get a mark for getting that far, but I'm going to simplify that right now to 3 over 2, because you can divide top and bottom by 2. Now we use y minus b equals mx minus a, where a and b is just one of the points. I'll just pick the first one, a and b. You could pick the other one. So I get y minus 14 equals 3 over 2 x minus 8. Y minus 14 equals 3 over 2x. 8 divided by 2 is 4. 4 times 3 is 12. So minus 12. Y equals 3 over 2x plus 2. And then swapping in our P and D. P was y-axis and D was x-axis. So we can write in the end P equals 3 over 2 times D plus 2. Now notice in this case, usually at this point if I had a fraction, I would times through, but I want to really have P equals to work out the cost. So it's much easier in this case to leave the fraction in, but you might want to take the fraction away and put it back in if you want. Okay, part B says calculate the cost of a journey of 5 miles. So D is 5. So I can just do for part B, D equals 5. So P equals 3 over 2 times 5 plus 2. So that is 15 over 2 plus 2, which is 7.5 plus 2, which is equal to 9.5. So the cost, P equals pound sign £9.50. Don't leave your answer as 9.5, that's not money. So you need to get £9.50.
It's been Mr. Clem from Clem Maths. Today we've done the whole of National 5 Maths for everything in the 2023 National 5 Maths exam. I really hope that you found this video useful, and please, if you did, give it a like and a thumbs up, maybe subscribe to the channel, but more importantly, take your time, revise, don't stress out about the exam, and really good luck to everybody that's been watching along this year. I really hope that this has been helpful and you do really well in your exams. Take care, stay safe, and goodbye.